Hi everyone, I'm Naman Bhalla, and today in this video we are going to discuss about SQL queries and some of the common type of questions that appear regarding to SQL and basics DBMS knowledge that is required if you want to be good in DBMS. So the topic for today is SQL interview questions and concepts. Okay. So today we are going to first start with a basic coverage of different concepts that you need to know before you even start diving into doing SQL queries. You must know that, okay, how data is arranged, how to arrange data, how to structure your database in a good way, such that it is very fast on the queries that you have to do and all other things. Okay, great. So let us first begin with what even data is and why is data important. Okay, the efficiency of any company, any business depends upon the data it has. Okay, I'm like the user data that you have, or you have the data about how people are behaving, and that information is very relevant for you to make business decisions. Okay, so data is of a prime importance and at the core of a company's functionality. Okay, now how will you arrange data? To arrange data you need some kind of system, right? What can be those systems? One very basic way to arrange the data can be, hey, that let me just actually create a file, and suppose I have a data and my data is something about, let us say that we are developing database for a system, okay, for a university. So what will be my data like? Let us say that I am a university, so my data can be like something about students, right? I can have some data about students. I also can have some data about my faculty, right, or my employees. Let us say for now, let us keep it short, and let us say that we have only data about these two things. Now, how might I save it? One way to save it is very rudimentary way that, hey, let me actually create a lot of files on my machine, and then in those machines, let me store the data. So let us say that there is a file, something like students.txt, and let us say that there is another file that is employees.txt. And then suppose you have multiple students. Let us say that there is a student who has a roll number 1 and his name is Abhay. And suppose he has a batch. Let us say that we are storing these three information. We store it something like 1 Abhay, and let us say it is 2016. So that is a very fine way to store data. There's nothing wrong with it, right? But is it a good way to store data? That depends. That depends upon what kind of data that you have, right? So that is where the concept of a database management system comes. That, hey, how will you even store the data? What optimizations will you do so that the storing data is relevant to you? Because you don't just store data, you also use it, right? So you have to do some queries upon it. You have to also fetch the data back again to make some business decisions or resolve some queries, right? So there are two important decisions that you need to do. The very first decision is storing the data, and the second thing is querying that data, right? Without these two operations, our database management system is irrelevant to you. Okay. So our DBMS is nothing but a system software that allows you to store the data and query the data, along with providing a lot of security constraints and other things, which we will tell as we go into this video. Okay. So those are the primary two things that we need to maintain with us. Okay, so that is what a DBMS comes from. How can we structure a DBMS? One way to structure, I mean, like, how will a DBMS inside itself structure itself, right? So the one way can be like, even a DBMS maintains a file. That is a fine way to structure. That might be something like it is maintaining documents. Okay, can there be any better way to structure your data inside a database management system? What do you store the data about? In your computer, you store the data about some things, right? You store the data about something. Like here, you were storing the data about students. You were storing the data about employees. Suppose there is also users. You have some, let us say that probable students or people who have applied to you. So there might be something like applicants, which you are storing the data about. Okay. So you are storing the data about something, and for each student, for each thing that you are storing data about, you are storing some things about that thing, right? So these things that are called as entities. So entities are nothing but about what or about whom are you storing data. Okay, and about whom you are storing data, and what data are you storing, right? You are also storing some kind of data about things. Like, for example, for students, you are storing the roll number, you are storing the name, and you are storing the batch ID. That depends upon the business decision as to what you want to store. So there are two things. The very first thing is the things that we are storing the data about, which, as I told, is called as entities. And then there is attributes or fields. What data about entities are you storing? Now, let us consider our real world use case. Is data in silos? No. There is always a connection between one data and other data, right? So, for example, for a student, let us say in a university, you might also need to maintain that which courses have been enrolled by a student. So, somehow you also need to maintain a course enrollment data set, right? So, let us say that another kind of entity can be course enrollment. For course enrollment, what do you need to store? You might need to know that what is the course number, and also you might need to store that who is the student who has enrolled for that course. So let us say the two things that you need for a course enrollment is nothing but a course represented by an ID, and also a student, which is probably represented by a roll number. Okay. Now suppose these are the three data sets that your university has. If we see here that, hey, we were maintaining the student roll number here, as well as we were maintaining the student roll number in the data set for this student, we were maintaining that roll number here. So data set is not in silos. Our data at what particular location has some kind of reference to data at other particular entity, right? Okay. This is known as relations between data. So now we observe one pattern in it that, hey, we are maintaining data about something, and we are also, because we have maintained data about different things, then we somehow need to maintain relations between them. So a database management system which stores data in the form of entities and the relations between them can be known as RDBMS, or relational database management system. Okay. What kind of RDBMSs exist? There are different varieties of RDBMS that exist in the open source industry and are used very widely by different companies. Some of the popular examples can be MySQL, and another popular one can be PostgreSQL. Okay. Now, in these two terms, you would have noticed one thing repeating, right? You would have noticed one thing that was repeating was SQL. What is this SQL? This SQL stands for Structured Query Language. This can be considered as a default language, or I mean, like, it's not actually default, but it's one of the most popular languages to query upon the data that you had stored. Because as we recalled earlier, whatever data that you have stored has also needs to be fetched, right? I mean, like, if data is just stored, it's of no importance to us. It's just increasing your storage. I mean, like, it might be relevant to us in the future, but anyways, at one time we do need to assess it, and that is why we are storing it. Okay, cool. So now SQL, as we told, is the most important language that is used to fetch data from the relation RDBMS systems. Now let us see how SQL works. Okay, so the very first important thing that we see from SQL word itself is a query. What is a query? A query is nothing but a statement that you execute to fetch the data from an RDBMS. What is one important thing about computers? One important thing about computers is they do what you tell them to do, right? But they also require that you should be very well defined. You can't just say random things to it and expect that it will fetch you the exact results that you wanted, right? So you need to be very well defined. So you need to know that how do I write queries in SQL, right? Otherwise, you won't get the data that you actually intended to get from the SQL query. So the prime focus for the today's session will be how do we write SQL queries? What are the important constructs that we need to know while we write a SQL query? Most of the SQL functions in different DBMSs are almost same. So that is why we are going to abstract away from one particular technology of a DBMS. We are going to structure about common abstractions that we have in a DBMS management system, and then you can run those over any kind of system that exists. Okay. So the very first type of query, the very first important function or important feature to do a query is the select statement. This select statement is the most important thing that you need to know to run any query. What does select do? I mean, if we just go by the definition of the word, select means selecting something or choosing something from the data that you have. right? So that is the whole function of a select statement. So a very simple select statement can be that, hey, suppose you have a student table and you are maintaining three things about a student. Let us say that he has an ID, he has a first name, he has a last name. Okay. And you need to know that, hey, who is the student who has an ID of 1? Suppose that is the thing that you need to know. And there are multiple students. Let us say the student with ID 1 has a first name of A and a last name of B. Then there is a student with ID 2 who has a first name X and last name Y. And you need to know that what is the first name and last name of the student who has ID of 1. So you basically need to know A and B. How will you use the select statement to write this? It's very simple. You will say select. What is this? This is first name. So I need to select the first name. What do I also need to select? I also need to select the last name. So select first name, comma last name. Where do I need to fetch from, right? So suppose someone asks you that, hey, you need to get this thing. I just tell you that, hey, you need to get a, suppose a biscuit. Where will you get that from? You will ask me that, where should I get that from, right? So that information is relevant. So the next thing is from. Where should the query language get the data from? So suppose it gets from a particular table. The name of the table is student. So select first name, comma last name from student table. Okay. If you write just this query, what will you get? I mean, suppose you're a computer and someone tells you that, hey, you have to just get first name and last name from the student table. You don't know. I mean, like, you go to the student table and you try to see that which first name and last name I need to get. You see there are a lot of first names and last name. So best way is that you bring all of them, right? If you just write this query, what will it return? It will return the whole table as it is. It will get the first name and last name of all the students. So basically what you will get will be A, B, and XY. Why did it return this? Because you didn't specify which first name and last name should the SQL get, right? Okay, so let us be a more precise. Let us say that, hey, you have to select first name and last name from student of the person who had the ID 1. So you need to know that, hey, the ID should be 1 at that place. So you can write where ID is equal to 1. And finally, you can terminate the statement with a semicolon. Okay. So what will this return? This SQL query will return you A and B. And why will it return? This is because of three statements that we just saw here of SQL, that is select, that is from, and that is where. These are the keywords in the SQL query language. Great. So I think the basic idea about a select statement is clear now. Now let us discuss about a subquery. I mean, like, we will be discussing multiple of these where clauses from in depth, but let us first discuss the basic high level concepts before we delve into details. Let us discuss what a subquery is. Now, let us say that you need to give degree to some students. You are a university, you need to give degree to students, right? The students who are just going to pass in this particular year. Okay, now how will you give degree to those students? Suppose you have two tables. The one table that you have is a students table. Okay, in this students table, you have an ID, you have the name of the student, let us say, and let us say that you have batch. Okay, suppose this is a simple student table that you have, and you need to give degrees to the students who are going to pass in batch 2020, let us say. So then someone comes to you that, hey, some of those people who had the batch of 2020 are actually not going to get the degrees because they failed in some courses. Then you ask that, okay, where should I know that which students failed? So that person tells you that, hey, there is also a table that is failed students. In those failed students table, you have IDs of the students who have failed. Okay. So now you need to give degree to those students who have the batch of 2020 but have not failed. So somehow you now need to use what is here to give the result of your final query. How will you do that? To know which are the students who had failed, you need to select all the IDs of students from here, right? So somehow you need to select IDs from failed students. Okay. But the task that is given to you is not to fetch the IDs of failed students. The task that is given to you is to tell who are the students who are going to get the degree. Who are the students who are going to get the degree? Those are the students who actually have the batch, the batch of 2020 in the students table. So also you know that you need to do this, that hey, select ID from students where batch is equal to 2020. Okay. So now you need to select those IDs from this students table where the batch was 2020, but you don't need to select those IDs that were present here, right? So what will you do? One very simple way, I mean, like one thing we will come to that in later of section of this video. There is also one statement which can do it in one line. But let us say you can say that where batch is equal to 2020 and ID should not be an ID not in. And where should the ID not be? The ID should not be in the result of query of this particular thing, right? So ID not in, select ID from failed students, right? So here we saw that, hey, we used one select statement inside another select statements, right? This is also known as a subquery or a nested statement. By the way, this not in is a keyword in SQL where you can select those things that are not present in the result of a particular table as well. Okay, but now let us say that you ask me a question that, hey, how does SQL know that these and these are the same thing, right? I mean, like, how will it know that? I mean, there should be a basic thing that whatever data is here should be whatever the data was present in what was I mean, like, retrieved from the earlier query, right? So that is a constraint that SQL asks you. I mean, like, that's your responsibility to maintain that the data type of the data that is taken from here is equivalent to the data that is here. Okay, so that is what a nested statement is. Okay, now what kind of nested statements can be? There can be two kinds of nested statement. First can be correlated. What does a correlated nested statement means? What does a relation with two things means? Relation between two things means that, hey, one of those things cannot exist without the other thing, right? So a correlated subquery is a query in which none of the, I mean, like, in the, which this subquery, this is the subquery, right? Subquery is not independent, but needs the main query to execute itself. So it can't exist independent of each other. So if there is a correlated subquery, then what can be a different kind of subquery? The second kind of subquery can be non-correlated subquery. In which the main query, for example, in this particular query, this was the main query and this was the subquery, where main and subqueries are both independent. Okay. What do you guys think was the above subquery? Was it a correlated or was it non-correlated? As we can clearly see that in the above example, the select ID from failed students can exist without even the main query existing, right? So it is definitely an independent or a non-correlated subquery. Okay. Okay, so now we have discussed select, but now you also see that we were doing where, right? We wanted to check about, we wanted to do some kind of assertions that, hey, I need to know data about those things. I need to know the data where a particular thing is maintained, right? So let us discuss the common clauses. This where is known as a clause. Okay. So I mean, like, what is a clause? I'm like, in normal term, in normal real day life, you might have thought about clauses in your agreements or contracts, right? Those are the things that you need to check. Those are the things that you need to ensure. So where is also a clause. So let us discuss SQL clauses. Okay, one of the clauses that we have already discussed is where. There are three other main important clauses. Those clauses are group by, having, and order by. One of the best parts about the SQL query language is that, hey, each of the words in the language are actually very, I mean, like, self-descriptive, right? Because, you know, I mean, like, you just see the word and you kind of get an intuition that, okay, what might this thing be doing? What can the where thing be doing? Where clause just allows you to filter the records based upon some conditions. Okay, for example, what were the conditions? What were the conditions in the original query that we had written? In the original query that we had written, the condition was that ID should be equal to 1. Let us say that our data had multiple students, and those students, let us redraw a student table. In the students table, we again are having ID, we are having a name, and let us say we are having batch. Okay, and let us say that there is an ID 1, 2, 3, 8, 9, 11, 12. Okay, the name is A, B, C, D, E, F, G, and batch is 2020, 2021, 2020, and 2022. Okay, so now I ask you that, hey, you only need to give me the students who have, the first condition is who are going to pass in 2020, that is who have their batch as 2020. And the second thing, I also ask you that their IDs should be less than 10. Okay, so then what will your where clause have? Your where clause will have two things. What are those things going to be? Your where clause will have, first will be batch is equal to 2020. And what is the second thing? The second thing that your where clause will have, ID is less than or equal to 10. So this is a simple where clause, and a where clause can have multiple things, multiple assertions that need to be maintained. And those assertions can be grouped with and. And if there is and, what do we think that other statement might be? I'm like just similar to and. Suppose if I'm like, if we have done programming, there is and then there is a or as well, right? So suppose I had, instead of writing and, I had written or. What would the result of this query be? This query will result into all those students who either had a batch of 2020 or had an ID less than or equal to 10. So the query will return this. The query will the query return this or not? The query will return this. Why? Because the ID is less than equal to 10. So this will be returned. This will be returned because this is also satisfied. This is also satisfied. This will be returned because ID is less than equal to 10. This will be returned. This will be returned because batch is 2020, but this won't be returned because neither is batch 2020 or I did this. Okay, great. So that is where clause. Now let us discuss the order by clause. Before we discuss group by and having, because they are interrelated, first let us discuss the order by thing. What do we mean by an order? What do we mean by an order? Order is nothing but an arrangement of things in the way you want them to be arranged, right? Consider order by something similar to sorting. Okay. Now I ask you that, hey, please return me the list of all the students. Okay. I just tell you this thing that, hey, please return me list of all the students. You go, you fetch all the students and you return it to me. But in which order will you return? Did I ever tell you that? No, right? So there might be a thing that you ask that, hey, hi, in which order should I return it? So for example, let us take a normal use case. Suppose there are a lot of things in a restaurant, a lot of things in a restaurant menu, and those things are grouped by being a starter or being the main course or being a dessert. Okay, suppose a starter is represented by a 1, a main course is represented by a 2, and a dessert is represented by a 3. Okay, now one person asks you that, hey, he has maintained in a DB table, he has maintained one starter, one main course, and one dessert. Okay, suppose he has maintained a DB table which is something like what will I eat, what to eat. Okay, okay, so which is food ID. It also has food name. Okay, and also it also has food type. Okay, so food ID can be something, I mean, like suppose you are representing breads by something, you are representing some kind of pastries by something like that. Let us say there's a food ID which is 201, which can have a name of pastry, which let us say is a dessert, right? So let us name it 3. Then there can be something he has selected 1. There are multiple things he has selected as main course, so there can be 2 things. Let us say that he has rice and he has some kind of meal or something. Okay, so then there are 100 or 120, and then there is one starter that he selected. Okay, let us say it is XYZ and it has 300. Okay, and this is a starter, so this is 1. In which order will the person like to eat? The person will like to eat in the order that he will have like to have, I mean, like he will have the main meal in between and then the dessert, right? Okay, so you need to, so you just go to the DB table and you say that, okay, return all the meals that the person had selected in what to eat. If you return the me's in the order that exists in the table, then you will actually disappoint the person like anything, right? So you need to return those meals in the order of what type of food they are. So you should return meal here, then you should return main course, and then you should return the dessert, right? So you need to order the meals that you bring by food type. So how will you do this thing? So you will say select food. Let us say you select the food ID. Where should you select those food IDs from? You will select those food IDs from what to eat. From what to eat. Okay. But in what order will you select those? You will select those in order of food type. So you will say order by food type. Okay. So then your SQL query will return this thing first, then one of those two things. I'm like, it can return any of those two because they have the same food type, and then it will return finally the dessert. Okay, so this is the order by clause. Now let us discuss the other two things, having and group by. Okay, what is having and group by? I mean, like, what is the intuition that you guys get that, okay, what might having represent? Okay, so let us first think of group by. But let us first think of group by. Group by is a thing that is used by aggregate functions. Okay, let us actually talk about group by here. Group by is a statement, is a clause that is mostly associated with aggregate functions. Okay, so what does this mean? Aggregate function means that, okay, those functions who actually compute upon a large amount of data and then return a result. So there can be two kind of functions, right? One kind of function computes upon a single argument and then returns a value. So those are known as scalar functions, which we will come to in depth again. And then there is an aggregate function. Okay, suppose aggregate function, the examples of aggregate functions can be sum, can be average, and those. Okay, so let us discuss about a simple thing. So let us say that you are using a having clause. So you want to know that you have to return those students, I mean, like, who lived in India and the student ID was greater than 5. Okay, so you need to return count of those. So what you will write? So you can say that select count of student ID, comma, country. So I mean, like, let us say that we had a DB table. In a DB table, with every student, I was also maintaining his country. Let us say in this student table, I had a country of first person was India, then this was USA, this might also be USA, this can be UK, this can be India, and this can be India, and this can be India. Okay, so you need to know that which are the people who have a country of India. So that is the very first thing to know. That, okay, so let us say that we need to know who are the students who don't have country India. Let us say we do the reverse. We need to know who are the students that don't have country as India. Okay, then you get the students. So which will be the students that you will get who don't have country as India? You will get this, you will get this, you will get this. That's it. Okay. But now you need to order them in some way. Someone tells you that, hey, once you have filtered those students who don't have country India, please group all the students that had a country together, right? So group all the students who had country USA together, then group all the students who had country UK together, and so on. Okay. So how will you do that? You will say that select count of student ID, comma, country from students. Okay. Where what should be the thing? The thing should be that country is not equal to IN because IN is representing India. Okay. Okay. Now you get all those students. Now you need to group them by countries, right? You need to group the countries that had USA together. Okay. So group by country. Okay. So all the students that have the same country are now together. That's it. Suppose you return this. What will this return? Now, what a group represents, a group basically creates a single group of people who had the same value here. Okay. So let us decipher this particular query one by one. Okay. In this statement, the very first thing is select from students where country is not equal to India. This thing will give you 2, 3, and 8. So you get these three things. Okay. Then the next thing that you do, you are grouping them by country. So then you get two groups, right? There are two students that had USA and one student that had UK. So now you will get two groups, which are 2B and USA and 3C and USA. And the final one was 8D and UK. Okay. So these two students were in the very first group and this student was in the third group. Okay, now you have grouped them by country. Now what do you need to return? You also need to return the count of student ID. Basically, how many different student IDs were there where in each groups. So because count is a aggregate function. It works upon a different thing. It works upon a set of inputs and returns the number of inputs that are there. So what will be here? It will be 2. What will be here? It will be 1. So what will it return? It will return 2 USA and 1 student from UK. So writing this query helps you to find the number of students from each country where the country is not India. Okay, I hope that is clear. Now let us discuss having. Suppose I have written this query. Okay, and then I tell you that please return only those countries, where the number of students were greater than 1. Okay, so you need to return only USA and not UK. Okay, so having allows you to do filter on aggregate queries, filter on aggregate functions. So you can say that where having the count of student ID, so you can here write having count of student ID, or let us say ID, which is greater than 1. So if you write this thing, you are only going to get USA. So the difference between where is just a filter upon a normal attribute value, whereas having is a filter upon an aggregate function, the value returned by an aggregate function. So the question is why we use having instead of where clause in group by clause. So having actually used to, because see, once you have done group by in functions, then you need to do some kind of query upon these groups, right? So consider this as different, that you have done a grouping. Here you have done a grouping, and then out of those groups you are selecting particular groups that had something as this. Okay, so that is why you need to do a having kind of thing. Okay, great. Now we had actually, when I was discussing this particular thing, that hey, let us say that we had to select the students who we were giving degree to. Okay, then I tell you that hey, we also don't need to select the students who actually failed. I told you that hey, we will run one query and then we will run a sub query, and the basically whatever the value was not in the second sub query, we will put in a not in clause and then give, right? This thing can be done in one query in SQL. So let us discuss three functions, which are union, minus, and intersect. Okay. By the way, I'm like, if you have studied set theory, these clauses seem very similar to what we discussed in set theory, right? Is there any kind of relation between set theory and why these terms are like that? Yes, there is. The reason for that is because the relation that RDBMS system, when they were actually originally the paper of RDBMS, actually is representing all these things with notations of set theory. So an RDBMS is nothing but a implementation of set theory, that okay, how you will be doing operations upon data in terms of how you do operations upon set. Okay, so each table is actually a set and not order table. So that is why there is no guarantee as to how the data will be arranged in the table. It might happen that this data is somewhere here or this data is somewhere here, because these are sets and not tables. Okay, Acha. Now let us discuss union, minus, and intersect. What is union in a set? What is union in a set? In a set, let us say that we have two sets, A and B. In one set, we have three things, 1, 2, 3. We have four things here, 4, 2, 1, and 5. What is union of A and B? By the way, union in set function is represented by U sign. So what is AUB? This is nothing but 1, 2, 3, 4, and 5. Basically, union is the combination of all the values that is present in any of those two sets, right? If you also notice here that, hey, 1 was present here as well, but 1 was present here as well, right? But in A union B, we got 1 only once. So a union removes duplicates, returns duplicate only once. But what if you want to return, if 1 is present here and here as well, you need to return it twice. What if you want to return 1, 1, 2, 2, 3, 4, and 5? For this thing, there is a union all in SQL. Okay, union all keeps all the duplicates. Okay, so what the union statement basically does is union statements returns all the values that are present in any of the sets. Present in any of the sets. Okay, now what is minus? So I tell you that, hey, I have some things here. I have some things in this particular system, which is, let us say, A, B, C, D, and E. These are some things here. I tell you that you need to return everything that is here, but should not be here. Okay. So what will you return? I mean, like, suppose, let us say that you have 5 things and 2 things. You need to return every of those 5, but those 2, but not those 2. So you do 5 minus 2, right? In maths, you do a 5 minus 2. Similarly, in sets, you can do a set A minus set B. Suppose this is represented by set A. This is represented by set B. If you do set A minus set B, you will get all those queries that are here. I mean, like, they should be here, but they should not be here. Suppose there was an F here as well. So what are the queries that are here? These are A, B, C, D, and E. Okay. And what is the second thing? The second thing is they should not be here. So out of these things, what are the things that are here? So they are B. So B will be removed. Well, that is A. So A will be removed. This is F, but F is not here, so we are fine. And the final return from here will be C, D, E. Now, do you guys think that we could have actually directly used this minus statement in the previous question? What would we have done? Instead of writing where not in, we could have just done minus here, right? So if we were doing here, we could have just done minus here and we would be fine. Correct? Great. So that is the minus query. And then what is intersect? Intersect is also a set function, and intersect between a set A and a set B is represented by an inverted U sign, and it says it returns values present in both set A and set B. So let us say that set A had the values 1, 2, 3, 4, 5, and 6, and set B had the values 2, 4, 6, 8. Now, if you do A intersection B, it will return those values that are present in both of those sets, right? So it will return something that are present here as well as here. So those are things like 2, 4, and 6, right? Great. Now let us actually, I mean, like, now we understand that, okay, what are these commands doing, but how will we actually write them in SQL? How will we use them in a SQL query? In these SQL queries, these statements are between two select statements. So how will it be represented? So one way can be that he select name from students minus select name from failed students. What will this query do? This query will return all those students, the names of all those students that are students but are not failed students. Now I tell you that you need to return everyone who is a member of my university. So suppose my university can have students and he can have employees. Okay. And it can also have, I mean, other things, but let us say that for now these are the only 2 things, and you need to return everyone who is member of the university community. So now you need to represent a union of those 2 things, right? Either that person can be a student or that person can be an employee. So what will you do? You will do select name from students union select name from employees. Okay. Now there can be one thing that, hey, I need to select those students. I need to select those students who are actually, let us say, living in a particular city, who are living in Delhi. Okay. Let us say, how will we do that? So we will say select name from students. Okay. Those are all the students, right? And then I have a different table. Let us say my database was arranged like this, that I had a students table and I also had a Delhi students table. Okay. So I need to select all those students that are first of all students, and the second thing that they are also Delhi students, right? So I will do an intersect. I will intersect with select name from Delhi students. So this will return me all the list of people who are present in this set as well as this set. Okay, as I discussed earlier, these terms are actually related to set theory, and an RDBMS is more of like sets and not of more like arrays. Okay, or what we say, a table. Okay, so these are sets. This is set 1, this is set 2, and this is a set operation of intersect. Okay, so there is a query that is it minus or except. This is a minus. Okay, this depends upon different database management systems as well. Okay, I mean, like, depending upon different DBMS system which are implementing, these concepts might be known by different names, but mostly these are known by the common terminology of union, union all, intersect, and minus. Okay, great. Now let us discuss one of the most important topics that are there in database management systems, that is joins. What is a join basically? Now, as we discussed earlier, that hey, data doesn't appear in silos, right? Some of the data might be here. Also, some information about that student might be in some other table, similarly, and so on, right? Let us say that we are maintaining data about an organization. Okay, let us say that we are maintaining data about an organization. So in the organization table, in the organization data set, we have first thing, we have employee table. And the second thing that we have is, let us say, employee salaries table. Okay. Okay. So now the thing is that I need to know the salary of a particular employee. Okay. I need to know the salaries of particular employee, or I need to return to you. Someone comes to you that, hey, please return me. Let us say that this employee table is storing ID. He's storing the first name. He's storing the last name. And let us say that he's he's storing the role. So these are the four informations that are maintained in an employee table. And let us say the employee salaries is nothing but an ID, and there is a salary. Okay. Now someone comes to you that, hey, please give me the list of all the employees along with their salaries. So now what you need to do is you need to return some data from here along with some data from here, right? So you need to return a group of things. So suppose there was an ID one, the first name was A, the second name was B, his role was, let us say, he is a CEO, and then the salary of ID one is, let us say, 10,000 some units. Okay. Then there is an ID two, first name is A. Two people can have the same first name, right? The last name can be C, and let us say his role is a VP. The salary of VP is something like, let us say, 8,000, and so on. And what you need to return? You need to return 1 A, B, CEO, and 10,000, 2 A, C, VP, and 8,000. So now you see that, hey, to return my answer, I need to actually fetch two tables. I need to fetch data from two tables. Okay, but how will you ensure that this data corresponds to this data, and this particular row, this particular record corresponds to this particular record? How did you come to know that? You came to know that based upon the ID here and ID here. You joined, or basically you selected those, you combined by the ID. Where this ID matched, you combine those, right? This is the use of joins. It allows you to fetch data from two different sources, from two different tables, based upon something that matches. Okay. So now how is this happening? Let us discuss different type of joins when this will become clear. So the very first join and the most important join is the inner join. Inner join allows you to basically join based upon a particular column, and the data should be present in both of those things. So suppose there was a ID 3 and he had a salary of 6,000, but you don't see any employee with ID 3 here. So what is even the use of returning this data, right? So if still the same person asks you to return all the employees along with their salaries, you only need to return this, correct? Because you don't know if this 3 person is here. And let us say that there was an ID 5, and his first name was D, his last name was E, and he was also a VP. But you don't have his salary information. So you don't have his salary information. There is no salary information available here. So you only need to return those data whose information is available here as well as here, right? So this is the concept of an inner join. Okay. So let us discuss that how this inner join is going to work. So this is going to, I mean, like the normal function, how do you write is that select star from first table. By the way, what is this select star doing? This select star does nothing but returns all columns of the table. All columns, okay? Not the rows. Okay? So we select star from table A, and then when we have selected everything, so basically I have selected everything from this table, then I also need to select everything from the employee salaries table, right? So then I will also select star from table B. Okay, but I need to join them. I need to join this with the second thing, right? How will I join this? I will see that, hey, ID here matches the ID here, right? So what I can do is, rather than doing this, so I say select star from table A. I select everything from the first table, and I join. And I join with what? I join with table B. That's it. This is equivalent to select star from table A, inner join table B. So writing inner join is normally in most of the DBMS is not mandatory. Okay. So when you have done this, you get the result of this based upon these two tables. Why? How it automatically selects that what should I group by? It sees that, hey, there was an ID column here, there was an ID column here, as well as there was an ID column here. Because both of those columns had the same name, so it makes sense to, I mean, like it makes sense to choose that as the common name and then group by that, okay, and then join by that. So that is the inner join. That is the most common join that is used. The second type of join is left join. This is a left outer join, but let us call it left join. What it says is select everything from left side, select everything from left side, and if corresponding values are not there on the right side, fill those values with null. Let us take the above case. So suppose instead of doing an inner join, where the value was present in left side as well as in the right side, I was doing a left join upon this table. So what would I be returning? So I will definitely be returning everything which was from the left side. So I will be returning 1, I will be returning 2, I will be returning 5. But there is no corresponding data for row 5 on the right side. So for those particular things, for all those values of this thing, I will put null and null in the salary. So what will I be returning? I will be returning 1 who has a first name of A, B, CEO, and his salary is of, let us say, 10,000. I will be returning 2 A, C, VP, who has a salary of 8,000. I will also be returning this because this is a left join. So I will be returning 5 D, E, VP, but I don't have any information about this, so I will replace this by null. So this is the left join. As there is a left join, so obviously the opposite also has to be true. So the opposite is right join. What this right join means? This right join means select everything from the right side. Now you have to do the first selection on everything that is on the right side. Now, if the corresponding data of the similar column is not available on the left side, fill the left side with null. Okay, fill the left side with null. If corresponding data is not available on the left side, fill the left side with null. So what will it return? It will return 1, it will return 2, it will return 3. For 1 and 2, there is the data on the left side, but not for 3. So what I will be returning will be 1, 2, and 3 are the IDs. For 1, I know the first name, I know the last name, I know the role. So this is CEO, and I also know his salary. Okay. For 2, I also know everything. So I know that his name is A, his surname is C, it is a VP, and it is 8,000. But there is a person 3 whose first name and last name I don't know. So what will I return? I will return 0. Sorry, I will return null, 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 and 6,000. So this is a right join. Okay, so we have done left join, we have done right join. What can be other thing? The other thing can be, if there is, select everything from the left side, select everything from the right side. If left side has corresponding data in right side, obviously do the join. But if there is no data on the right side, fill with null. Similarly, if there is something on the right side which doesn't have a corresponding data on the left side, fill that with null. So it's a combination of left join plus right join. And what will it return? It will return, and I'm like, it's known as the full join as well. Full join. Select everything, join if a match, else fill left side or right side by null, depending upon the situation. So let us see what will be the full join output for this particular table. I will be returning everything from the left side, right? So I will be returning 1, I will be returning 2, I will be returning 5. So it will definitely be returning at least these 3 things. Okay. But I will also be returning 3. So I will also be returning 3 because it is present on the right side, but it is not present on the left side. So I will also be representing this thing. So if you see, this is the output of left, this is the output of right. What is the output of a full join? Output of a full join is nothing but union of left and right, right? So basically, what will be the output of a full join? It will be 1 A, B, CEO, who has a salary of 10,000. Then there is 2 A, C, VP, who has a salary of 8,000. Then there will also be 5, whose name is D, E. Then he's a VP, but I don't know his salary. But I am also doing a right join, so I will also be returning this. So it will be 3, null, 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 and I know his salary is 6,000. So this will be the output of a full join. Now there is one more thing that is also there, that is a cross join. So let us say that we have two sets. Basically, each select query is nothing but a set, right? So we have a set A and we have a set B. And there are multiple values here. Let us say they are A. These are different rows, right? So these are A, B, C, D. These are, let us say, F, G, and H. Okay. If we have two things, if we have two different sets, and you have to make a Cartesian product or a cross product, Cartesian or cross product. Okay. What this means is that, hey, combine all the values from the left side with all the values of right side. So basically, what will be the final output? There will be this one row, these. So there are 3 rows. Similarly, there are 3 rows from here. There are 3 rows from here. And similarly, 3 rows from the final D. If there are 4 values in the left side and 3 values in the right side, how many values will be there in the final set of the cross join? If it is a cross join and one side has 4 values and the right side has 3 values, the final values will be nothing but 4 multiplied by 3. Why? Because each row on the left side is going to produce 3 rows, because it is going to be combined with every value on the right side and thus produce 3 rows each of those. So we will be getting 4 into 3, which is 12 as the final table. Okay. So there's a question that what if there are more than 2 tables? If there are more than 2 tables, you can use just parentheses to say in which order do you need to find the outcome. Okay. And all these functions are actually commutative. I mean, like union and intersection functions are commutative. So any of those order works. Suppose you have to do intersection of 3 sets. Okay. So then you can do select star from A. Then you can do union, select star from, let us say, B. Now, whatever all these values we got from here, then we need to do intersect, select star from C. So we can put this in parentheses so that this is executed first, then an intersection with this thing will be executed, and there will be an outer parenthesis as well. So I mean, like, we can group those statements together as we want them to. Okay, great. Now we have been discussing a lot different kind of joins, but what are we actually working upon? We are actually working upon the data. We are actually working upon getting the data. Suppose you have the data, what is your main idea? I mean, like, you want to get that data as fast as you want to, right? I mean, like, you want that, hey, please get me the data as soon as you can. Okay, so you need to ensure that my queries should run fast. How will you make the queries run fast? I think everyone must have heard about arrays, right? Everyone must have heard about arrays, and you guys would have also heard about hash maps. What is the difference between searching a value in an array and searching a value in a hash map? Searching in an array is a linear time operation, whereas searching, I mean, like, if the array is not sorted, and searching in a hash map is probabilistic order of 1, right? Okay, so what we observed from here was that, hey, in a hash map, we use some kind of different space or some other optimization or some other conversions to improve our search time complexity, right? Yeah. So if we want to optimize, if we want to speed up our queries, we can probably use some other memory. We can use some memory to speed up our queries. Okay. Using some memory to speed up queries is known as indexing. Okay. Now let us say that you know that, hey, a lot of times, I need to I need to find all those students who had a score, who had total score greater than 80, who had total score greater than 80. So suppose you have a table, suppose you have a student table in which there is an ID, there is a name, and there is a total score. Again, recall that, hey, SQL is not a array. SQL is a set. Okay, and there is no order in a set. A set can be returned in any random order. So suppose there is an ID student here who has a name A and whose score is 60. Then there can be 2 whose name is B, whose score is 10. Then there is a 3 whose score is 90, and let us say his name is C. Then there is 4 whose also name is A. It can happen that 2 people have the same name. Then it's also 80. Then there is 5 whose name is L, let us say, and his score is 5. Okay. Now, always there are a lot of queries that come that, okay, each query you have is that, hey, find all the users, or find total number of users who had sum or who had score greater than equal to X. If it was an array, I mean, like, if suppose this was the final data set that you had, if this was the final data set that you had, and you knew that you are getting a lot of function calls just finding score greater than equal to X, would you like this data to be arranged in some kind of order? Would you like this data to be arranged in some kind of order? You would like that, hey, this data, if this data is sorted by the total score, right? If this data is sorted by total score, then you can answer each of these queries using binary search in order of login, right? So you need to do some kind of post processing. Okay. And also you need to know what are the common operations that your database has, or what are the common queries that your database has. So this is known as a database indexing. What is an index, first of all? An index is nothing but a data structure. To study which is the data structure that actually does that is not the scope of today's lecture, but if you want to study that, you should definitely see about that B tree and B plus trees. What are these? So this is how indexes are actually, I mean, like, most of the times implemented. So an index is nothing but a data structure that provides quick lookup. Okay, because you need to arrange the data. I mean, like, hash table is also nothing but a data set, right? So quick lookup based upon a query, based upon queries in a column or a set of columns. What do I mean by set of columns? Why set of columns? Okay, sometimes it can happen that, hey, suppose a lot of times that you have queries that are actually not just based upon a particular column, but are based upon a conjunction of multiple columns, right? That all the students who have a name beginning with, let us say, B, name beginning with B, and who had a score of less than equal to 80. Okay, so then you probably need an index upon two columns, which can be name, and the second thing can be total score. So how to choose which will be the columns that you will index upon, that depends upon what your application is doing. What data is your application assessing a lot of times? If you see that a particular data is being assessed a lot of times, it makes total sense to add an index over those particular columns. How will you create an index, by the way? To create an index in SQL, you run this. So you run a statement like this, create. So by the way, I mean, like, if you ever have to create something in SQL, you use the create statement. If you have to create a table, you use this. You have to create a database, you use this. In this time, you have to create an index. So you do create index. You can also name the index. Okay, I mean, like, you can call the name of index, something that you want to do. So let us say that I call this index name score. So I create an index whose name is name score. Then I also need to specify what are the columns that I'm creating that index upon. So I'm creating that index upon columns that are name and total score, but these columns can be present on a large number of tables, right? These columns can be present in a lot of tables. How to decide that which is the table I'm talking about? So I also need to mention the table. So I will say on students name and total score. So if I run this particular query, it will create an index upon these two things. What is the disadvantage of an index though? The disadvantage of an index is that it needs extra space, but that is fine. An extra space is not a big issue, but it can slow down writes. So let us say that, okay, let us say we don't know about B trees or B plus trees, but you had to actually implement an index yourself. Okay, if you had to implement an index yourself on this particular thing, you can say that, okay, I will always maintain this table in sorted order of table score. And then if insertions happen on this particular table, what will be the time taken to insert? It will be linear, right? So I'm like, because you always need to ensure that the table is sorted, so then you can't do it in order of one or in constant time. So indexes can slow down writes because they need to process the new data that it achieved. Okay, that is an issue with indexes, but otherwise they are actually always beneficial. Okay, great. Now, what kind of indexes can be there? The indexes can be of two types. There are two ways in which you can classify indexes. The very first way in which you can classify indexes is unique and non-unique index. What does unique index says? Unique index basically allows you to maintain that if a particular data is if there is a duplicate in a particular column or in a particular set of columns of the data. Suppose you have a data in which you want to always ensure that no two no two students have the same name. No two students have the same name. How can you do that? To do this thing, you can create a unique index on name column of students, right? So what will happen is that at any write, whenever a write happens, it will check the index if a constraint that was set in any of the index is being broken or not. Okay, if we had not indexed this thing, checking this would have been a more complex operation or a more computationally expensive operation. But as we have maintained an index over that particular column, it immediately allows me to check that if that constraint of uniqueness is being broken or not. Okay, so unique indexes are there to ensure some constraints in there. Then what is the definition? Why is there a need of non-unique indexes? Non-unique indexes exist to speed up the query. So while unique indexes, the main purpose of unique indexes is to maintain the constraints or data integrity, right? They need to ensure that the data integrity is maintained, but the function of non-unique indexes is only to speed up the queries. Okay, and that is the biggest advantage that non-unique indexes have. Okay, now there is also another way in which we can classify the indexes. This way is known as clustered and non-clustered indexes. Okay, the very first thing that I told you was that, hey, a relational database is not a table, but it's a set. Okay, so that means there is no definite order in which the data would actually be stored in memory, right? It could be stored in any way. Okay, now if I tell you that my query is always to select people in order of their roll numbers. If I say that I have a student table again, okay, I have their roll number, and let us say that I have their name. And I tell you that my queries are always going to be selecting students in the order of their roll numbers. But as the databases are set, so the roll numbers can be arranged in any order. So 3 can be here, 2 can be here, 4 can be here, and like this, name is A, name is B, name is D, let us say name is C. Okay, so data can be arranged in this order, but I tell you my queries fetch students always in order of roll numbers. Now, what would you like to have? Will there be something that makes immediate sense that, hey, if my queries are always fetching data in the order of roll numbers, should I arrange my data in the order of roll numbers? If I have arranged my data in the memory in the order of roll numbers, it will speed up my queries, right? Because then I need to just iterate over the data and I'm done. Okay. So what clustered indexes allow you? Clustered indexes, they change the way data is stored in the database as per the index. So if I create a clustered index based upon roll number, what will it basically do inside the memory, inside the storage where the data is actually stored? This will change to 1, 2, 3, 4, and 1 has C, 2 has B, 3 has A, and 4 has D. So now, if my queries are always in the order of roll numbers, they will become very fast. Okay, so that is what clustered indexes are. But what are non-clustered indexes? Non-clustered indexes maintain a separate data structure to optimize queries. Let us just see only this definition of clustered indexes. If clustered indexes change the way in which data is stored in the memory, can I have more than one clustered index? No, right? Because if I have more than one clustered index, then I need to store the data inside the memory as per the conditions of two indexes, which is not possible, right? Because there can be only one way in which I can dictate the order the data has to be stored in the storage, right? Okay. So one issue with the, or basically one thing with the clustered indexes is, the very first thing is that there can be only one clustered index, while there can be multiple non-clustered indexes. Okay. The second difference between clustered and non-clustered index can be that the clustered index changes the order. Clustered index affects how data is stored in memory, while non-clustered indexes don't. Okay. 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 Let us say that we have these two things. If we have a clustered index upon a particular column, and also if we have a non-clustered index upon a particular column, which of those do you think will be faster? If we have a clustered index, basically because clustered index is actually directly affecting the data set, right? And it is storing the data in the way you are assessing. Also, you have a non-clustered data set. Which of those do you think will be speeding up the queries more? Obviously, the clustered index will have even faster queries, right? Clustered indexes have faster performance with respect to non-clustered, okay? Because in a non-clustered index, you actually first talk with a different data structure, and then that data structure depicts that, okay, now fetch this data, now fetch this data. Whereas in a clustered index, the data itself is stored in that manner, and thus it helps you to speed up those queries. Okay, great. Now let us actually talk about something called as views. What are views? What a view is, let us say that I need to have one source of truth. Okay, so I say that there is always one source of truth, and a lot of times I'm storing data about students again, let us say, and I am also storing their gender. I have students, suppose I have their ID, I have their name, I have their batch, and I have their gender. Okay. Okay, so let us just write few things. A 2020, gender can be male. 2, which can be B, which is 2020, gender can be female. And 3 can be A, let us say C, whose batch is 2018, who can be, let us say, again female. And 4 can be T, 2019, can be male. Okay. Okay, so this is the data that we have. Okay, now what I tell you, that there is one person in my university who ensures that whose job is to ensure to do data analysis upon the data of females. Okay, suppose her job is that, okay, let me actually analyze the data of females, do some operations with it, try to find out some information from it. Okay, how can I ensure that the repeated task of that particular employee in my company, whose task is only to just do multiple queries upon the data of females? Okay, so this is students. Then one way can be that I create another female students table. So one can be that I create another female students table, and that female students table will be like this: name, batch, gender, and then there will be 2 P 2020 female, then there can be 3 C 2018 and female. That is one way in which you can do that. Do you guys realize that there is some issue with this? There is some issue in which the data is being arranged here. The issue with that is, now if a new student gets added, suppose there is a new student that gets added whose ID is, let us say, 5, name is E, batch is, let us say, 2019, and she is also a female. Now we don't just need to put the data here, but we also need to put this data here. Okay, And if by mistake you forget to put this particular data at this side, then the employee whose job was to ensure the data, I mean, like to do some operations or analysis over the female data, will go wrong. Okay, so what would you ideally like to have? You would ideally like to give the employee who is working upon the female data a view, a subset view over the students data, right? That hey, he can see what is the data of students, but only that subset of the data of students where the gender was female, right? That makes sense. How can we do that? We can do that by creating a view. So a view is nothing but a select statement, that that gives an intuition of a different table, an intuition of a different table, while in reality data is present only at one location. Let us see how this works. Like, suppose we have this data only, then what will a view do? A view will actually, let us say that this is, it kind of like is a camera over that thing, that okay, it allows you to see this thing but with a filter. It allows you to see this thing but with a filter. So here, this view is, let us say that the female students is no longer a table, but female students is a view. This view behind the scene is just running a select query, which is just selecting those students from the students table that have gender as female. But the employee whose task was to work upon female students can now use it as she would have instead used a female students table. That is what a view does. So view basic. And now what would happen? Now if you ever do a write here, now if you add a new thing, you just need to add it here. As soon as you add it here, this view will automatically get updated because there is only one single source of truth. Okay, awesome. Now let us discuss some of the I mean, like, how can we do the where clause? Okay, I mean, like, we have a where clause, right, that we have discussed. One way in which we have used the where clause till now is using equal to's, right? Using directly checking for equality or checking for less than equal to and all those things. Let us discuss something called as wildcard patterns and other things that you can use in the where clause. Okay, so where clause, let us say pattern matching. Okay, so in where clause pattern matching, let us discuss different kind of things that can happen. The very first thing is wildcard patterns. Suppose a complaint comes to you about a person, and the person who actually did the complaint didn't know the exact name of the person who did the crime. Okay, and then what he tells you, that I just know one thing, that hey, his name starts with KH. That's the only thing that you know. Now you can't just do a DB query. You can't just do a SQL query where name is equal to KH, something like that, right? So you would like the name. I mean, like, so you want to do a SQL query where name starts with KH. Okay, how can you write such query in SQL? In SQL, you can have pattern like K percentage. What KH percentage means? This means KH and followed by any sequence of vectors. This can represent KH. This can also represent KHA. This can also represent KHAY, and similarly, right? Great. So this is what a percentage or a wildcard pattern is. So how will you use this wildcard pattern? Suppose the task that is given to you is find all students whose name begins with KH. Okay, suppose this is what the data that is, I mean, like, the question that is given to you, and the data set is something like this. This is the student table, and in this student table, you have an ID, you have the name, and you have, let us say, batch. That should suffice. So there is a student with ID 1 whose name is Khyati, and the batch is 2016. Then there is student name number 2 whose name is, let us say, Aman, and whose batch is also 27, let us say 2017. Then there is student 2 who is Khayal, let us say, that might also happen. Then his batch is 2016. You need to find all the students, and let us say that there is also one more whose name is Kamal. Now, what will this query do? So we need to find all those students whose name starts with KH, right? Whose name starts with KH. So that means we need to return this, we need to return this, and that's it. Okay, we don't need to return this because this starts with KA. So what SQL provides you? The SQL provides you first the wildcard pattern, and the second thing is a like statement, is a like keyword. So you can write thing like that here, select star from students where name. See, when we actually know the exact name, we use the equal to sign, right? But now we don't know the exact name. So instead of equal to sign, we have to use like, where name like, and then I will say KH percentage. I hope that is clear. Okay. Now, rather than finding all the students whose name is KH, I tell you that, hey, the question is changed, but I need to find all those students in between their names. Suppose A and AMA is coming. Suppose I need to find all the students that have AMA in their name, anywhere in their name. I mean, like, it might not be the starting characters, it might not be the ending characters. What can be a real world use case? Suppose what do we say that, okay, I mean, like, an examination is going on, and the invigilator finds a chit, and the invigilator finds a chit. On that chit, the name of a person was written. It was AMA. Now the invigilator wants to know who might be the students who would have done, whose chit that might be. Okay, so now you need to find all those students that had AMA in their name. How can we do that? To find all those students that had AMA anywhere in the name, we can write percentage AMA percentage. So what this percentage symbol is representing, basically, if we see from this particular thing and from this particular thing, is any sequence of 0 or more characters. Okay, so this percentage AMA will match Aman. This will also match Naman, but this won't match Amit. Okay, so what can we do? We can just write a statement, select star from students, where here we wrote where name like this. So here we can write where name like percentage AMA. Now, we had also discussed, I mean, like, in the very beginning of this video, that if we want to remove a subset of the queries from my statement, right? So I had used a not keyword, right? I had used a not keyword. What this not keyword allows you to do, this not keyword allows you to omit those results present in something else, present in something else. So let us say that my just query just changed. I somehow know that, okay, the person who had did this, I mean, the person who did this thing, his name just doesn't have AMA. That's the only thing that I know. Okay, then what can I mean, like, how can I find all those students that had, how can I find all those students that didn't have AMA in their name? I have to find all those students that didn't have AMA in their name. I can just use this not keyword. I can say select star from students where name. First we were doing where name like. Now we don't want the name to be like something, right? So we can say where name not like percentage AMA percentage. So if we run this query, this will return Amit, but this won't return Aman. Okay. Now we have discussed three things. We have discussed percentage at multiple places. We have also discussed not. There is also a specific sign. Okay, a wildcard for a specific position. That is nothing but the underscore sign. Okay, what it says, suppose I want you to find all those people, all those students, the third character in whose name was, let us say, M. Okay, so if I only want you to find all those students, the third character whose name was M, but anything else can be anything else. Okay, so I want to return Naman, and I want to say, let us say that there is something called Lambot. I need to return this as well. I need to return this as well, but I don't need to return Amit. Okay, suppose this is what I want to return. Okay, so how can I do that? I know that the first two characters can be anything. The first two characters can be anything. Then there should be an M. Then there can be any number of remaining characters. Okay, if I write percentage M percentage, will this work? No, this won't work. Why will this not work? Because this will also return Amit. Because Amit also satisfies percentage M, and all this as percentage. So what can I do? I can say that the first two characters should be underscore. So underscore matches any character, any single character. Okay, so first two characters should be underscore, then there should be an M, then there should be percentage. What this means is that the first two characters, so that numeric value, that there should be a percentage, then there should be an M, that should be a percentage, that is fixed. So I can find all those students who had the third character as M by something like select star from students where name like slash underscore underscore M percentage. Okay. Now let us take talk of another question. Let us talk of a question where I had to return all those students whose name had more than four characters. I had to return all those students whose name had more than four characters. How can you do that? If the name has to have more than four characters, we know that the first three characters can be anything. The first four characters can be anything. So we can just write that by underscore, 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 underscore. That means the first four characters can be anything. Then it can be percentage. There can be any number of characters after this. So a query to select all those students who had name greater than four characters can be something like select star from students where name like underscore 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 and percentage. Okay. So that was in wildcard pattern searching of strings in a database. Let us also talk about what kind of database, like what kind of operations can actually have can happen on a database. Because if you are using a database management system, you need to know what are your requirements, right? What kind of data that you want to have, okay, or what kind of operations happen, or what kind of requirements are there from the data set, so that you can choose a database system that actually conforms to those requirements. So there can be two kinds of database management systems that are commonly known. The first type of database management systems are OLTP, and the second thing is OLAP. So how to distinguish between these two? You can distinguish between these two types of data sets using the word T and A. Okay. What does T means? T means transactional. What does A means? A means analytics. Let us try to understand the difference between OLTP and OLAP. So as we see from the name that OLTP database is more for transactional things. Okay, what do we mean by transactional things? Transactional thing is a large number of queries, but each query is very small. Okay, like let us say that very simple thing. Let us say that I just need to select all those. I just need to increment the value of something by one, or let us say that I still have the students table and I have their marks as well. Let us say, so I have students tables, I have their marks. And let us say the student table has something like this: ID, comma name, comma marks. Okay, so there is ID 1, A, initially his marks are 20, then 2, B, 30, something like this. Okay, so now my queries are things like, hey, my queries something are like that, hey, insert a value or update a value, things like that. These are very small operations, but these operations are happening a lot of times. In those scenarios, you need a transactional database management system. So what that transactional database management system will need to do, it should have actually a very fast response time. You will be very sad if just to create a like, if just to submit a like, it takes a lot of time for the Facebook's database system to actually store that like in the DB and return you that, okay, you have liked that post. Okay, let me actually just tell the full form of these things. OL stands for online and P stands for processing. So online transactional processing and online analytical processing. Okay, so this is the difference between OLTP and OLAP. Okay, so in an OLTP database, I need fast response time. Okay, so my CPU requirements are not that much, but I need to be able to serve a lot of requests in very fast. Okay, so normally OLTP databases are actually distributed. Okay, because you need to serve a lot of requests or so lot of parallel requests which are normally short, so you actually distribute your load. Whenever you actually have to have a lot of small queries, the best way is that you distribute those things and have multiple different computers handle it rather than having a vertical scaling approach. Okay, whereas consider you are a company, consider you have a database of a lot of users being stored since long. Okay. And then every 2 months or every 1 month, at the end meeting, you do a very big processing over those database. You try to find all those users who had posted more than X messages, or you find all those students who had actually attended more than 5 classes, and then who had actually also solved more than X contests and solved those things. Okay. So in online analytical processing, these databases are useful for business analytics and intelligence. Smaller number of queries happen, but each query is quite complex, can be quite complex, we will say. Okay, because I mean, like, one query might be fetching from a lot of tables and doing a join between them and trying to find a lot of other things. Also, in OLAP database management systems, other things that are actually, I mean, like, if you're doing a business intelligence, visualization becomes very important, right? So visualization, etc., are common features. Okay. So in this thing, being distributed is one important aspect, but in this thing, having a large support for visualizations and other thing is a more important task. Okay. Now let us actually talk about a very important thing in database design. I mean, like, how will you even create I mean, like, how did we decide that what tables do we need to create, or what do we need to store in what table? How did we decide that? Let us discuss this. Actually, this is a very, I mean, like, important topic as in terms of database management systems, in terms of understanding database management systems. This is normalization. Normalization allows you to have good database design. Good database design in terms of what? In terms of how we are arranging entities and relationships between them. Okay. So normalization also allows you to reduce data redundancy. Okay, let us say I had the student table again. In the student table, now I'm also storing the address of everyone. I'm also storing the address of everyone. Okay, so let us say that student has ID, he has a name, he has a city where he lives, he has a pin code, and these are the things that I need to store. Okay, so let us say that this is the database. So let us say that we have ID1, his name is A, he lives in Delhi, and his pin code does not live in Delhi because Delhi has multiple pin codes. Let us say he lives in a city XYZ that has only one pin code, and let us say that the pin code is 110001. Then let us say that there's a student 2 whose name is B, who lives in city ABC, and the pin code is 133001. Then there's a student 3 who also lives in city, like, whose name is C, who also lives in city XYZ, and the name is 111001. Okay. Suppose after a few days, government decides that, okay, we will be changing the pin code of the city XYZ. What can happen? What can be an issue in my this database design, in my this database schema design? The issue can happen is that, hey, suppose government says that the city with XYZ will now have a pin code of 127201. Suppose this is the pin code that the new pin code of XYZ has to be. Now, if this happens, what you will have to do is you will have to go on this student table everywhere where 110001 is there. You have to change 127201, you have to change 127201, and all those things, which is a very bad design, right? What can also happen is that, suppose there was also another student C, let us say G, he lived in city XYZ and had a pin code of 11001, but you somehow forgot to change this. And that's a bad thing for you. Now your data at some places is storing the pin code 127201 for the city XYZ, but at some places it is storing 111001. That means the data is not consistent. What do we mean by that? We mean irregularities in the information. So what would you ideally like to have? You would ideally like to have is that, hey, all these cities, I mean, like, the city and pin code, because a city can be recognized just by the pin code, right? So I would ideally like to have is that somewhere I'm maintaining the pin code and the city name. If I am somewhere maintaining the pin code and the city name, I can ensure that these consistency issues are reduced to minimum, right? So what will be very good for me is that, let me have a ID, name, and pin code here. or let us say, instead of having one table storing this, I can have a student table that only stores ID, that stores name, and that stores city ID, right? And I have another table, which is city table, that is storing city ID, city name, and pin code. Now we have 1A and let us say 1 here. Also we have 3C and 1. We have 4D and 1. Now we have 2B and 2, let us say. So we can say that the city ID 1 has name XYZ and has a pin code of 110001. City ID 2 has name ABC and 133001. So now if government decides to make the change, you only need to make one change, that is here. And this thing will automatically conform to new changes that happened here, right? So this is the advantage that you get by making your designs of databases very good. Okay, so these are known as normalized databases. Okay, but how will you decide that there is a need to improve the database design? Let us discuss normal forms for that. There are 6 normal forms actually, but greater than 3 normal forms are not actually used much. So we will be discussing here 1NF, 2NF, because those are more prominent. Let us discuss what 1NF says. A 1NF a table or a database schema design is known to be satisfying 1NF if there are no multi-valued attributes. What do we mean by no multi-valued attributes? Suppose you have a library management system, and in a library management system, you store which books have been allocated to a particular student. So you have a table, let us say allocation table, in which you have a student ID and you have a list of books. Okay, so suppose there is a student whose ID is 1 and he had rented, let us say, 5 books. So those books had ID 101, 120, 113, 120, and let us say 121, and let us say 180. Okay, so there can be a student 2 who has rented 3 books, let us say 11, 113, and 21. So on. This database schema design in which any of the table can have more than one rows is, in which any of the column can have multi-valued attributes, because this attribute has multiple values. This is not just a single value. This is not just an atomic value. So this does not satisfy 1NF. So how will we convert this data into 1NF form? How will we convert this data into 1NF form? We can change this data into 1NF form by splitting this data. Like this. Student ID and books, and say 1. Here's 101, 1, 120, 1, 113, 1, 121, and 1, 180. Similarly, 2 has 11, 2 has 113, and 2 has 21. Okay, this satisfies 1NF. This does not satisfy 1NF. Okay, so that is how you convert a data set that is not satisfying 1NF into a data set into a schema design that satisfies one normal form. Let us discuss about second normal form as well. 2NF data, the exact theoretical definition of this is that there should not be any column, or a set of columns that can be uniquely identified, by anything other than the primary key or the candidate keys. What are the primary keys and what are the candidate keys? We will discuss in a moment. But let us take care of this thing. Let us see the example that we had here. Let us see the example we had here. What was the primary key of this table? Let us firstly define primary key as a row, as a column value that has to be unique. For any record in the table. So, for example, if we see, the ID has to be unique. No two students can have the same ID. That is the main source of distinguishing between any two records. Okay. So what it says is that, let us see this pin code and this city thing. Do we think here that pin code actually doesn't need this ID to be uniquely identified? Pin code can be uniquely identified if we just know the city. But city is not the primary key, right? I mean, like pin code can be identified by the city, but city is not the primary key. That means there is a subset of columns in my schema design that can be uniquely identified without even the primary key, which is ID. So how can I convert this data set into second normal form is what we just did here. But the conversion that we had done here was nothing but the conversion of a data set that does not comply with second normal form into a data set that complies with the second normal form. Let us actually take one more example. In which we can do that. Okay. Suppose, let us say that this example is actually present also on the interview with practice forum of this. So what it says is that, hey, let us say we have a students table. We know the student ID, we know their name, and we also know if he's a Mr. or if he's a Mrs. Okay. Then we say that, okay, let us say that we have students, we have ID, we have name, we have gender, and we say that what is the salutation that we use for them. Okay. So let us say that salutation can only be Mr., Miss, or let us say it can be Doctor. Okay, these are the three salutations that are allowed. Okay, can we somehow know these three things by some other thing? I mean, like let us say that currently I'm maintaining students like this. One whose name is A, whose gender is, let us say for now we have only Mr. and Miss. Okay, we name it A and gender is male. We have student B whose gender is female. We have student 3 whose gender is A, whose name is B. This salutation will always be Mr., this will be Mr., and this will be Miss, right? But actually what we realize here is that, hey, if we just know the gender, we actually know the salutation. So what happens if I suddenly decide that or I will call all the males not Mr. but suppose Master? I might decide that. Then I will have to iterate over the students table. and update this which is, and that can lead to consistency issues. So this is where like, if these are the two columns that can be uniquely identified by something other than the primary key, we split these set of columns into a different table. So we split this by only maintaining gender here. So let us say that we are maintaining ID, name, and we are maintaining gender ID. Okay, so we are saying 1, 2, 3, she is A, he is B, he is A, then gender is 1, 2, 1. Then based upon gender ID, I can store the name. I can also know the salutation. So I can say that gender ID 1 is male and the salutation is Mr. And the gender ID 2 is female and the salutation is Miss. So this is how I convert a table or convert a schema design that's not into the second normal form into something that is a second normal form compliant. Okay, great. Now let us discuss one last thing before we actually end the today's lecture is something called as procedures. Okay, something called as procedures. In normal functions, when you would have, in normal programming that we do, we don't just write code sequentially, right? We don't write code sequentially, but we actually make our schema design procedural, right? We say we have a function called print this, we have a function called do specific task to ensure that a SQL code, that means our normal program is modular. Okay, that should look modular. Okay, how can we do the same thing in SQL? In SQL, we have something called procedures. Procedures are nothing but select statements. They are also select statements that can be identified by a function call. We can create procedures and each procedure is doing nothing but a select statement. Okay, so each procedure is doing nothing but a select statement. They are select statements that are identified by the name. Now, these procedures can be something that also manipulate the data, right? They can actually change the data as well, that whatever is in the data set at that particular location. So suppose there can be a procedure, or this can be update statements, modification statements. Okay. So one example for that can be, suppose this was the thing that happened, that hey, you decided to call all males master. Okay, suppose you decided to call all the males master. Now what you will do, you can write a procedure You can write a procedure which is called change salutation. It can take in gender and it can take it new salutation, right? And then this recursively runs the SQL query and then changes it. Okay, now when we are actually discussing this, let us actually discuss what kind of SQL statements we had, what kind of SQL statements that we had. And let us actually parallelize its intuition with how you build a house. When you are building a house, what are the things that you need to do? Okay, I mean, like when you are building a house, first you need to decide that, okay, how will my house look like, right? How will my house look like? So that is basically definition. Okay. Then the second thing can be who will live in the house, right? Who will live in the house? Okay. What can be the other things? The other thing can be you put something in there, right? You actually put some value there or put some data here and all those things, right? So the other type of queries can be that, hey, you manipulate or you change the design, that you say that, okay, I will put one more thing in the kitchen or I will do these things. Okay. So those can be what we say controlling it, or we can say it as modifying it or manipulating it. Okay. And what can be the fourth kind of thing? The fourth kind of thing can be that, hey, you have manipulated, you have queried, you have I mean, like, you have defined the thing, you have queried, you have manipulated. You also say that who is the control, who is going to control the thing. I mean, like, who has what access. So these are the four things that are actually I mean, like, in SQL, these are the four kind of statements that exist. The very first kind of can be data definition language. These statements allow you to define how my data is going to look like. That, okay, this is going to have something like this is going to have something like these statements are create and all the statements. Okay, these can be create, these can be drop, these can be truncate. I should not truncate is not actually a data definition language. Then the second thing can be query. For querying in a database, what are the statements that we had actually used? One most prominent statement that we used for query in a SQL database was select. So that is a SQL statement that is used for selection, for query, right? And the third thing can be manipulation. These manipulations can be insert, update, and all those things, right? Insert this, do this, and all those things. Okay. What is one more important thing? One more important thing is who actually has access. Who actually has access to my table? Because data is very private, so you can't give the access to everyone, right? So you need to have some kind of control of who has access to the data. So I mean, like, in a SQL, the database administrator actually gives you a control that, okay, there is a user this who can actually create I mean, like, who can actually write to this data, or this user cannot write to the data but he can only read. So these control statements can be grant and revoke. So in a SQL, all the statements can actually be segregated into these four things. There can be a definition statement, which can be creating, dropping. This can be querying, which can be like select. This can be manipulation, inserting something or updating something. And these can be controls. These controls are allowed, I mean, like, these control statements are there to, I mean, like, give some read rights, read rights, or only write rights, and all those things to the database management system. Okay, so these are the four things that are there in this. Now let us actually discuss some, I mean, like, some tricky kind of thing. Let us discuss one tricky question that is normally asked in a database interview, and then we will. The question is that, hey, you have to create a new table, with structure, with exact data structure of another table. Okay, suppose there is a table called students, and you don't know that there is a table called students. You don't know this. Okay, so there is a table called students, but you don't know what is inside this table. So there is, suppose, ID, there is name, there is two, three more things, but only you know that there is a table called students, and you need to create a table called students copy, which should be having the exact same structure as the students table. Without knowing that, what is the structure of students table, how can you do that? So this is actually a very tricky question that is normally that can be asked. So what this, I mean, like, how can you do this thing? Anyone has any ideas here? Let us try to see what a select statement was doing. Select statement actually returned me whatever the data was present in my table, right? So if I don't know students table, at least I can run this select query to get the data in that form, right? So I can still get select star from students. Okay. But then what will I do? Now I at least know that what is in the data. What is the structure of students table? But what should I do now? What can I do? I need to store whatever was the structure that came from here into some other table, right? So SQL allows you another keyword which is into. I say I select star into student copy from. Now where am I selecting from? I'm selecting from students, right? Okay. What will this thing do? What will this statement do? If my statement is only this particular thing, what is it this going to do? Into does nothing but copy everything that was in the first table as it is to the next table. Okay. So for example, if students table had 1 XYZ, 2B ABC, and 3C DEF. Okay. So this statement, this is the students table. This statement will actually just copy everything as it is into the students copy table. Okay. But I don't want the data. I only want this structure. I only want this structure. How will I do that? I can say, because I have written a select statement, then I can have a where clause, right? Then I can have a where clause. Okay, I will have a where clause, but what to put in the where clause? I need to put something in the where clause such that none of these rows actually get carried forward here. So what? So the statement should be something that is always false, right? That is always false, so that nothing from here gets carried forward here. So what can that statement be? One very hacky thing is where 3 is equal to 4. This statement can never be false, right? This statement will never be true. This is always false. So select star, when the select star thing gets the table structure, it creates a new table, student copy, because we are putting into here. So it creates a student copy, but because the where clause was never satisfied, we actually never put anything there. Okay. Or actually we could have done where 0 or where false. That would have also worked perfectly. Okay. Great. Now let us actually discuss some of the aggregate functions of the in SQL that are present in the SQL, because that is something that people tend to miss out, because otherwise you have to see the documentation. Let us quickly discuss that, and then we will be ending the today's session. So let us discuss aggregate functions in SQL. Okay. So let us just list them down and let us see what those are. The very first function can be average, AVG. So this function takes in a list of values. And returns the numeric mean of them. Okay. One more function that we had actually discussed in the beginning of the lecture, in between the lecture, was a count, right? Count statement returns just the number of rows or the number of records that are satisfying that particular statement. So if I just do select count of star from students, what will this do? I'm saying the count statement just returns the number of records that satisfy my select statement, right? So if I have select and I'm saying select everything from students, so what is the count of everything? This is nothing but number of students. So one hacky way to get the number of records that you have is just select count star of students. That was perfectly fine. Okay, let us discuss other functions. That is min. Min also works upon a type of data. Then there is max. Because there is average, then obviously there also has to be a sum. There is first and last. What are the first and last doing, by the way? People tend to get confused by first and last. What is the, how are they going to be decided? They're going to be decided by the order, in which the rows are returned. So the first will return the first element in the order in which select statement would have returned the values. Are null values counted? Yes. If the whole row is null, but it is still present, so yes, that will be counted, because that record is still there, unless you have maintained primary key constraint, in which that case it will anyway fail, right? Yeah. So similarly, the last fetches the very last particular record for that particular element. Okay, when we were in the middle of the lecture, what we found about that? What did we observe about these aggregate functions? These aggregate functions allow you to group by. I mean, like they are used with group by and having, right? So these are the aggregate functions when you aggregate upon something, when you are doing an aggregate. So let us say I am going to take average of all males. Suppose the question that comes to you is that, hey, given a student table where student table is something like ID, name, gender, and score. Okay, you have to return average of males and females respectively. Okay, so the very easy question, very easy version of this is that, hey, I just need to return the average of all the students. In which case you can just do select average of score from students. But now you have to select average of males and female in different groups. How will you do that? In that case, you will have to group those students by their gender, right? You will have to group the students by their gender. So you will still have to select average of score from students. But now all the students are not one group. All the students are not one single group. There are multiple groups. And how are those groups being made? Those groups are being made by their gender. Okay. Select average of score from students grouped by gender. Okay. So this is how the group by statement comes into effect. I hope that is clear. Okay. Now let us actually discuss these are the functions that are aggregate functions. These are working upon a set of data. There are also other functions. Like many people feel that, okay, it's very difficult to, it's normally a better choice to use a programming language along with, like SQL. Otherwise, it's difficult to write a lot of things. But actually, SQL has inbuilt scalar functions. So what are those scalar functions? These take in one value and return one value. So basically, like in multiple programming languages, suppose you have a capitalized function, right? Suppose like in, let us say in Python, you have a capitalized function. Actually, let us write those functions in SQL only so as to not confuse people. So let us, in SQL, there is a function called uCase. If this function is nothing but this takes in a string and returns uppercase version of the string. Similarly, there can be lowercase as well. Okay. Then there are multiple other functions. There are concatenation of different strings. Then there are some mathematical functions which are actually useful. These are rand for random. Then there are round. One of the most important functions that I've actually personally used in my in real life environment is the timestamp functions. So if you are working with, let us say, data warehousing solutions like Redshift and all those things, timestamp SQL functions are very actually useful. So these can be like to timestamp. Then there can also be now function that returns the current date and time. So one thing, most people think that SQL is just about the query language, it's just about querying, but it actually has a very strong set of inbuilt functions that are available directly that you can use and do a lot of tasks that you can actually probably do with only programming. Obviously you can't do a lot, many of them, but it's more than what normal people think to be. Okay. Okay, one thing actually we missed out in the medium of the lecture was keys, right? We actually missed discussing them in detail. So let's just throw a brief light on them and then we'll be ending it. Let us discuss primary keys and foreign keys and how to create those and foreign keys. Even before we discuss primary keys, let us actually discuss a term called as candidate keys. Candidate keys are a set of column values which can uniquely identify every other value. Select a set of columns, actually set of columns which can uniquely identify every other value in a record. What do we mean by this? So basically, let us take care of a student's key. Let us take care of a student's table again for the last time. So let us say that student has an ID, he has a name, and let us say he has marks. Okay, and that's it. Or let us say even as a gender. Okay. So let us say the student with ID A has name A, score 20, and gender M. Then ID student 2, he has name B, he has score 30, and gender female, he has student 3, he has name C, 31, and male. Okay, so suppose I just tell you the ID of the student. If I just tell you the ID of the student, you can directly go and say that, okay, the student with that ID had this name, had that score, and that name. Okay. So I mean, like, if you just know the ID, you can know all these three things, right? Let us only consider this table, the current values in this table. Do you think in this current value, name will also be uniquely able to identify all the other attributes? If I tell you that please get me data where name is A, please get me data where name is A, will it be able to uniquely identify all the values? Yes. In the current set, it will be able to, because there is only one person with one name. So A has only one person, B has only one, C has only one. So if I only know name, I can directly get the score, I can directly get the gender, directly get the gender, and directly get the ID. Is gender enough? Is gender enough to get the data? No. Gender is not enough to get all the other values of the data set, because there are multiple people who have the gender male but have different name, different ID, and different scores. So the columns, that is for this example, name and ID, that can uniquely identify every other values are candidate keys. So candidate keys can be a single column or a set of columns. What is primary key then? Primary key is the key that the DBMS uses to uniquely identify a record. Okay. It can also be a single column, or it can be group of columns. Okay. So let us see the student and books table that we had actually written above, right? Above we had actually written a student table where what we had was that, hey, which student has rented which books. So there we had a student ID and book side and book ID, right? So if student 1 had taken book 201, he had taken book 202, he had also taken book 203. Then student 2 has taken book 101, he had also taken 202, he had also taken, let us say that there is a student 3 who has taken 203. Suppose these are the students and this is the table. What do you think can be a primary key of this table? Can it be only student ID? Can it be only student ID? No, because there is no, I mean, like, if I just tell you student ID, you can't uniquely identify the value. This student ID is associated with this book ID. I mean, like, there is this thing, this is also associated with this is also associated with this. So basically primary key can be can be I mean, it can be the set of columns whose value, if you know, you can uniquely identify a row. You are guaranteed to return a single row. Okay, so for this particular table, the primary key will be student ID comma book ID. Both the columns together constitute the primary key. And let us actually discuss how will we create a primary key. I mean, like, in a SQL statement, how will we create a primary key? To create a primary key, you can either do, the very first way in which you can do that is while creating table. So while creating table, you can do create table. You tell the name of the table. Let us say that the name of the table is students. You create table students. In this table, we are actually maintaining student ID and book ID. Let us talk about this thing. Let us say here we maintain the ID as this. Okay. So when we create a table, we have to tell what is the name of the column. And then we also have to tell what is the data type of that column. So let us say that ID is an integer. Okay. And I mean, like, let us for now keep it as it is. Then we say that, okay, we are also storing a name. Name is nothing but a string, right? In SQL, a string is a varchar. It's a variable character of how many characters max? Let us say it's 255. So at max, that can be 255 characters. And then here we have, let us say, score, which can also be an integer. And let us say we finally have a grade. I mean, like, let us say we don't have a gender for now. Okay. Then we have to decide the primary key. So we can write primary key, and in the parenthesis, we set what that primary key is. Okay, that is one way. While we create the table, we actually write what is the primary key going to be. But suppose you had actually created the table and you forgot to add the primary key. What will you do? If you forget to do something that you had actually written while creating a data or while defining the data, you can use the alter keyword. Alter keyword is used to alter keyword is used to alter the initial data definition that you had done. So you can do alter table students where and you first you say that I am now going to alter my table. So that means I'm going to add something to it. What I'm going to do, I'm going to add primary key, and that primary key is going to constitute only ID. That is how I use the alter keyword and get this particular thing done. Okay, so that is about the primary keys. Let us actually briefly discuss, I'm like, before we come to foreign keys, let us actually briefly discuss the constraints. Okay, so I also want that, hey, I tell you that there should not be any student whose name is empty. Okay, I don't want any student whose name should be empty. Okay, that means I want that student's name should definitely be present. So SQL provides us a list of constraints that we can use upon our data definition. Okay, so one of those constraints can be unique. Then the other constraints can be not null. Then there are other constraints like that can check a particular value. That, okay, unique constraint says that value in a column or a group of columns should never be duplicated. Okay, not null says value should never be empty. Then one of the constraints that we have discussed is primary key. That primary key by default says that it should be unique and it should be not null. Okay, then there is also one more constraint that we can say default. So I tell that, hey, if I somehow miss to give the value of a particular column, please set it to this value. Please set it to the default value. Okay. Then one thing can be check. This check statement can actually verify that a value is satisfying a particular condition. For example, I can say that suppose I also had a gender here. So I can say that it's a gender and it's in character. Okay. Then I can maintain a check that, hey, gender should be only M or F. Okay. So this is what this is what we maintain by gender. That, okay, I put a constraint that, okay, I can't, there's no predefined constraint. So let me actually create my own constraint that, hey, the value of gender should only be M or F. Okay. And the next, there is also one more constraint, which is the foreign key. And let us discuss this foreign key constraint now. Okay. So what is a foreign key? When we actually were creating the original thing, when we actually created the employee table very in above, what we had actually done, we had two tables, right? So the very first table that we had was employee data, in which there was an employee ID, his department, and let us say his title and all those things. Okay. Let us say we had one this table. And the second table was, let us say, employee salary. And this had employee ID, and this also had salary. Okay. So if we have these two things, does it make sense? Does it make sense that, hey, there is an employee, but an entry corresponding to him is not present in the employee salary table? Does that make even any sense? No, right? Because if there is an employee here whose department is, let us say, tech, and his title is, let us say, CTO. Then there can be another ID 2 whose department is, let us say, program management, and whose title is, let us say, hey, let's say it's a general one, it's program management 1. Then there can be another person 3 who is also a program manager, let us say his title is PM2 and all those things. And let us say there's 4 who is in tech and he's software engineer 1. Let us say these are the rows that we have. And corresponding to ID 1, I have a salary, let us say 2,000, let us say, and I have a salary 2, this is 3,000. I have a salary 5, I have 6,000, and I have a salary 3 who is, let us say, 4,000, and I have a salary 4 who has, let us say, 2,000. Does this make any sense? There is a salary of an employee, but that employee does not exist. This does not make any sense, right? There should not be. There should not happen that, hey, in employee salary there is an ID. There is an ID, but that ID is not present in employee, right? So we need to ensure that if an employee salary is present here, that employee ID should also be present here as well, right? So we can add a foreign key to the employee salary table, but what should that foreign key reference to? That foreign key should refer to the ID column of the employee table. Okay, so what can it do? It can say, how can we add this? I can say that, hey, When I create the employee salary table, I say create table employee salary. Okay, when I'm creating the table, I need to have an ID. Then I also, this is an integer. Okay, and I also need to have, let us say, the salary, which is also an integer. Okay, now I need to add a foreign key. What is the foreign key upon? Foreign key is upon this ID, right? Foreign key I add upon this ID. But what should this foreign key refer to? What should this foreign key refer to? This foreign key should refer to ID in employee table, right? So I say foreign key ID references, this references employee ID. Okay. So this is how I create a foreign key. If I forget to create foreign key, I can just, like we add primary key later, we can do alter table foreign key, alter table employee salary, alter table employee salary. And then what I do, I have to now add a foreign key, right? So I add a foreign key. I add a foreign key upon which column? I add a foreign key upon the ID column, and this references employee ID. Okay. So this is how I can add a foreign key later as well. Okay. By the way, like anytime when we have to do a modification to the data, whenever we have to do any modification to the data, we actually have to use this alter command. This alter, as we know, is a data definition thing, and this can actually, like alter the table, alter the definition of the data. This allows you to do that. Okay. Okay. Finally, I think there is one more confusing thing that I actually saw someone in the comments. What is the difference between drop, delete, and truncate? What is the difference between these three things? Like these three things in English wise mean the same thing, right? These three things mean the same, that okay, you are deleting something probably. Okay, but is there any difference between these things? Why does SQL has these three things? Like why? Okay, so the difference between these three things is that, hey, delete is used to delete a row from a table. Delete is just opposite of select. Okay, in select statement you select some set of tables to view, but in delete command, you select a particular set of records to remove them from your SQL table. Okay, so like what you can do is, suppose you have to delete all those students. Like suppose your university decides to remove all the students who had less than 40 marks. So what less than 40 scores. So your university can do delete from students. Okay, then you can use everything here where what you use in select statement. So you can use everything here. So you can select where, let us say, score is less than equal to 40. This will do what? This will just remove every, like every data from the student table, from the students table that had a score in which a student existed who had a score less than equal to 40. That is a delete command. Then there is also a truncate command. What this truncate command is used to do, this deletes all the rows. This deletes all the rows. But table is still there. But table and its definition, constraints, everything is there. Definitions, constraints are still there. And then the final thing is drop. Remove every existence of the table. Okay, remove complete existence of the table. So let us actually give you an intuition of this with a diagram. Okay, suppose we had a table like this, in which we have an ID, in which we have a score. Okay, let us say we have an ID 1 whose score is 50, ID 2 whose score is 60, ID 3 whose score is 20, ID 4 whose score is 10, ID 5 whose score is 70. Okay, let us run three commands here. Let us run, and this is ID and this is size. Okay, this is suppose the table, and let us say the first command that we run is the delete from students where score is less than equal to 40. What will this return to? This will change it to ID and score, and this has 150 because this is there, 260 and 570. Okay, other things will get deleted. You do truncate. If you do truncate, you are only remaining with ID, score. No data is remaining. Okay, nothing else is remaining. And if you do drop, nothing is remaining. Like there is complete empty thing. Nothing is remaining. Yes, Rahul, where clause can be applied in delete. That is what we have written here, right? Yeah. So let me actually give an example of how to write the truncate command. To completely remove the students table, you can do truncate table. Like to truncate all the data that is there in this. So you can do truncate table students, and to remove the students, I mean, like to go into this thing that there's no existence of students table at all, you can do drop table students. Okay, so they completely remove the data, or the second thing, the drop table actually completely removes the whole existence that is there of that data. Okay, yeah, so that's all that I had from my side today. I hope you liked the session. It went for around 2.5 hours. So yeah, thank you for being a very patient listener. And okay, and by the way, guys, I mean, like we have actually a very, I mean, like all these things we have actually written into a well-defined article as well on the InterviewBit platform. So that is present on this particular link that I just pasted on the chat. So please, I mean, like if you want to practice all these SQL statements, you can actually write those SQL statements there and see if the code, if the SQL code that you wrote was also good. Okay. Yeah, awesome. Have a good night. Please stay safe and stay healthy.
Hello everyone, I am Pragya and today we will be going over quite a bit of Python interview questions. Right now these questions are going to be about the core Python language, and these questions are going to be questions that were asked in top tech companies like Google, Flipkart, Amazon and other places that use Python extensively. Alright, so we will begin with very simple questions about what Python is and how things go, and then we will dive into a little more advanced questions about the Python language. Now note that Python is a very big language and Python is not alone, right? So Python comes with a large ecosystem with itself. So you might have heard of things like NumPy, you might have heard of Pandas, you might have heard of Matplotlib, right? And you might have heard of things like Keras and TensorFlow. Now, if you are interviewing for a Python position, it is very likely that the place you are interviewing for uses some of these technologies, right? Uses some of these libraries. Especially, it is very common for places to use things like Django or Flask, right? Now, today in this particular session, we will not be covering questions on these ecosystem topics. We will be conducting another session to cover questions on these. Today, we will be covering questions on core Python language, questions that are extremely important, questions that you will invariably be asked if you are going to any Python interview, right? So we are going to look at that. And for these particular things, we are going to have further sessions. Okay. Now, if you want some more questions, if you want some more practice material apart from this session, you can always go on to interviewbit.com or slash Python interview questions, this link right here. And over here, you will see a large repository of Python questions along with their explanations, right? And you will also see some multiple choice questions at the end that you can try on for yourself. We keep on adding things to this particular repository. So it is always nice for you if you can keep updated, if you can keep in sync with this particular web page. Okay. The questions that you see here, they are not tied to any particular rule. Whenever you go to a top company, right, or a company that uses Python as its core technology, for example, companies like DE Shop, a large part of their code base is in Python. At places like Google, Python is not the core language. They extensively use Java. However, a lot of systems in Google use Python. Like places like Instagram, places like Dropbox, they use Python extensively. Irrespective of where you are interviewing for, as long as you have Python written down in your resume somewhere, if you primarily use Python as your coding language, and if you're interviewing for any position that requires Python, then you can expect that you will be asked some of these questions. Cool. So let us dive into the very basic question. Let us start with a very simple question. What is Python? Like, what is Python? So, well, Python is a very high level language. It is an interpreted language. It is a dynamically typed language. It has a lot of features. It has a large ecosystem, right? And there are various advantages to using Python. Especially, Python allows you to write code very quickly, and it has a very high throughput for the developer. So whenever you have an application in which the developer time is more important than the computer time, you use a language, a high level language like Python. Also, Python allows you to very quickly experiment with things, which is why it is used extensively in the academia. So places like data science, places you have to write large pipelines of data, you have to experiment a lot, Python is used over there. It is also a very good academic language. So for teaching students, Python is a really good language. Cool. So let us dive into some details about Python. Please let me ask you a question as an interviewer. So what do you think? Is Python a high level language or a low level language? Well, Python is a high level language. Now, can someone give me examples of high level languages and low level languages? Low level would be things like C, assembly, COBOL. High level languages would be like C++, Java, Python. It has not a strict delineation about what high level and low level is, but Python is usually classified as a high-level language. Okay. What about things like strongly typed versus dynamically typed? So first of all, what do these things mean? What does it mean for a language to be strongly typed or to be dynamically typed? And once we know that, what sort of typing does Python use? So Python is a dynamically typed language, not a strongly typed. So we have multiple categorizations. So we have strongly typed and weakly typed, and we have statically typed and dynamically typed. Now Python is a strongly typed language, and Python is a dynamically typed language. Now, what do these terms mean? So a strongly typed language is one in which every particular variable or every particular data that is in memory has a strict type associated with it. For example, in Python, if I do something like as follows, so if I do something like the string one plus the number two, if I do something like this in Python, I get back a type error. I get back a type error saying that I cannot concatenate a string with an integer. So that means that the number one, and this particular piece of data, two, these have strong types associated with themselves, and Python does not automatically convert the types as and when it wants. So there are some constraints about what types can be used with what other types and what operators can be used with what other types. Contrasting this is weakly typed language, things like JavaScript. For example, if I quickly open my console over here and I go to the JavaScript console, in the JavaScript console, I can once again type something like 1. So this is a string. I can type something like 2, which is an integer. But I can also do 1 plus 2. And this surprisingly gives me back the string 12. Now, this, for a programmer, might not make sense. JavaScript is a weakly typed language. The string 1 and the number 2, they have the types associated with it, but they are not strongly typed. Types can be converted between any of those. So here we see that Python is indeed a strongly typed language. Now, what about a dynamically versus statically typed language? Well, you might have heard of languages like C and C++ or Java. In those languages, we usually write statements like this. So we say int I equals to 10, or we say float b equals to 20.3, or we say things like boolean flag equals to true. Right? Now, these are languages which are statically typed. At the time of writing the program and at the time of compilation, the compiler knows what the type of each variable is. On the other hand, in a dynamically typed language, the compiler need not know what the type of each variable is. For example, in Python, you can simply say I equals to 10. And later on, you can also change the type of I. You can say that I equals to true. So the type of variable I, it is not bound to something. At this particular point, the value that I is holding is an integer type. But at this particular point, the value is a Boolean type. So Python, as we see, is a dynamically typed language. All right. Now, that does not mean that Python does not support static typing. So there is something in Python called MyPy. So let me just add a new note over here. So there's something called MyPy in Python. MyPy is a static type checker for Python. So even though Python is dynamically typed, it supports optional static type checking. So you need not use it, but if you want, you have the liberty of using it. And what this does is, before you actually run your program, it will go through your entire code and it will tell you if you have made any mistakes related to the types. Okay. At the runtime, this does not have any effect. It is just before you run the program, it will check your code statically. All right. Now, there's one more very important distinction between Python and other languages, or one more important property of Python. Is Python a compiled language, or is Python an interpreted language? Interpreted language, if I can spell it. Well, Python is actually an interpreted language. Now, if Python is an interpreted language, haven't you come across things like the Python bytecode, or haven't you come across files that look like this, .pyc files? These are Python compiled files. What are these? If Python is interpreted, what the hell are these things? So an interpreted language versus a compiled language is not that simple to distinguish. In a compiled language, you have an explicit compilation step. Whereas in an interpreted language, you don't have an explicit compilation step. What happens in Python is you have some non-explicit compilation. So what happens in Python is you have your Python source code. That can be something like some file.py. This is your Python source code. Now, when you actually run this, so you are using something like the C Python interpreter. When you actually call Python some file.py, What happens is the C Python interpreter reads all the code in your file. It compiles it down. It compiles it down to a Python bytecode representation. It does that automatically. You don't have to compile it yourself. And once it does that, it starts executing it, executing it from top to bottom, right, in a step-by-step manner. Now, so this basically means that there is no distinction between the compilation phase and the runtime in Python, right? For you as a programmer, it doesn't really matter what phase you are in. You are either coding or your program is either running. You don't see that compilation phase yourself. On the other hand, for languages like C++ or languages like Java, in these you explicitly compile your program, and you might have to make some changes while compiling your program. So if you see a compiler error while compiling your program, you will go back to your code and make some changes. So you can have compile time errors and runtime errors in these languages, C++ and Java, whereas in Python you only have runtime errors. There's no compile time errors in Python. All right. Can you tell me the difference between things like C Python, Python, PyPy, things like that? So what are the difference between these things? So this is a very common interview question that a lot of you will come across, and it is very important to know the distinction between these things. In fact, this is not just important for interviews. This is also important if you are doing any sort of online competitive coding. So it might have been the case that you went to interviewbit.com or you went to codechef.com, and there while you are coding, if you choose Python, you will see many interpreters. So you will see something like Python 3.5. You will see something like PyPy. You might also see Python. Right. So what are these things? These are actually different Python interpreters, and there are also sometimes different variations or different styles of Python. Right. So let me go over a few of these. So by default, when we go to something like python.org, right, all of you are familiar with this website, when we usually go to python.org and we download Python from here, what we are actually downloading is the C Python interpreter. Right. Now Python itself is the language specification. Python is the language specification, just like C++14 is a language specification. C++14 is not a compiler. The GCC compiler is a compiler. Right? C++ is just a language specification. Similarly, Python is a language specification, and the C Python interpreter, which we usually see as python.exe on most systems, or just the Python file on Unix systems, that is an interpreter that basically implements the Python language specification. When we usually talk about Python, we are talking about the C Python interpreter. However, this is not the only interpreter that is available to us. We have many other interpreters. So, for example, things like Iron Python, right, or things like Jython. Now, these different interpreters, they are written in different languages. For example, the Iron Python makes use of the .NET framework, and it allows very nice interportability between .NET code and Python code. So you can import .NET code in your code. You can export. You can call .NET functions from your Python code. Similarly, Jython runs over the JVM, right? So over the Java Virtual Machine. Jython basically allows you to call Java code from within Python. Now, if you understand these, that might give you the hint that C Python, the default Python interpreter, this actually is implemented using C, and it allows you to easily access C code. So actually in Python, you can use C types and you can make use of C code. You could write a function in C and you can call it via Python. However, these are not the only interpreters. We have several other interpreters, things like PyPy. Now, this might give you the hint that, hey, this is PyPy, so this is probably Python written in Python itself. In fact, it is. So PyPy is a Python interpreter that is written in Python, right? If you all understand that, hey, Python is a really slow language, so PyPy must be ridiculously slow. On the other hand, on the contrary, PyPy is actually way faster than C Python. The reason is that PyPy has something called a just-in-time compiler, right? This is called a JIT. So what PyPy does is, whenever it is reading your file, it will identify hot parts of your code, parts that are very fast loops or parts that are being used very frequently, and it will compile it down to machine code on the fly. So that will cause a lot of speed ups for your code. Now there are other versions of Python, things like Python, things like TypeScript. These are not strictly different interpreters of Python. These are different styles of Python. So apart from providing the core Python syntax and the core Python libraries, they provide you other interpretability. For example, TypeScript is kind of a mix between Python and JavaScript. Python is a Python runtime in the browser, other things like that. All right, cool. So please understand this very carefully that there's a difference between C Python, Python, PyPy, Python, and things like that. And this is a very common interview question. All right. How do we write Python in Python itself? Well, by writing Python in Python itself, what we mean is that you have what does the Python interpreter do? What does the PyPy interpreter do? It takes some files, right? Takes your code files, it basically reads them, it parses them, right? And basically it creates an abstract syntax tree out of them, and then it executes them line by line. It executes them. Now this entire process, you can code this entire process with any language that you want. So if you code this process in the language called C, there is one such interpreter called the C Python, right? If you code this entire process in the Python language itself, then you will get a Python interpreter written in Python. All right, cool. So let us move on to the next questions then. Now let us dive into some more the nitty-gritties of Python. You might have also heard of things like Python 2 and Python 3. So this is a very important question for almost all of you. A lot of the times when you go to an interview, what you see is that people have something like this written in their resume. So they have this skill section in their resume, and in the skill section they write Python 2 and Python 3. Now, whenever an interviewer sees this in your resume, a very common question comes up in the interview, and the question is, can you tell me the differences between Python 2 and Python 3? And guys, this is very important. If you are writing, if you are mentioning both Python 2 and Python 3 in your resume, and if the interview asks you to tell the differences, you better know the differences, right? If you do not know the differences, that clearly states that you actually don't know the differences between Python 2 and Python 3, and then it does not make any sense to write both the versions in your resume. The same goes for if you're writing things like C++ coding, right, in your resume. A very common question that comes up is, what is this 14? What does this 14 mean? Can you tell me the differences between C++ 14 and C++ 17? Or can you tell me the differences? I mean, what's new in C++ 14 that is not part of C++ older versions? So it is very important for us to understand the differences between Python 2 and Python 3. Now, there have been a lot of differences between these two versions. Perhaps the most important ones were the Unicode support. Right. So Python 3, in Python 3, the string data type, the inbuilt string type, by default supports Unicode, whereas in Python 2 it does not. In Python 2 you have to use something else for the Unicode support. There are many other differences. So the most common difference that you know in Python 2 versus Python 3 is it's the print function, right? So everyone knows that in Python 2 you write print something like this. So print hello from Python 2. Whereas in Python 3, you will write print something like this. So print is now a function. Whereas in Python 2, print was a statement. This is a statement, not a function. Whereas in Python 3, this is a function. Right? So this is one of the more common differences that you will find in Python 2 and Python 3. Whenever you're trying to port code from Python 2 and Python 3, you will see this. Now, whenever you answer this in an interview, the very next question that will come to you is, if you're coding in Python 2 and you still want to use the print as a function, can you use print as a function in Python 2? Well, we can. There is something called the features module. So you can do from future import print function, and that will allow you to treat the print as a function in Python 2. So whenever you're dealing with legacy code in company, it will be very important for you to always have this sort of import at the top of your code, so that if the other person, if some other developer runs your code in Python 3 instead of Python 2, your code still works. All right. By the way, let me just give you a quick link. You can actually go to this thing. So wiki.python.org slash, yes, this particular link. So I will just paste that link over here so that everyone can see it. You can always go to this link, and this has a lot more details about the differences between Python 2 and Python 3. Now that we know that we have two versions of Python 2 and Python 3, which Python version do you think we should use? Well, Python 2 is kind of dead. Python 2 is no longer supported. There are no more security updates coming for it. So we should always use Python 3 when possible. So whenever you are working at these large companies like Google or Amazon, a lot of their legacy code might be in Python 2. So just saying that, hey, I completely work with Python 3 and I do not know anything about Python 2, or I do not understand the differences between Python 2 and Python 3 is not going to cut it. Even though Python 2 is dying, and even though you should always begin a new project in Python 3, it is still important for you to understand the differences between Python 2 and Python 3. All right. However, please always use Python 3 when possible. And if you are forced to work with Python 2, always use the future imports whenever you can. Always use modules or libraries that allow you to interport between Python 2 and Python 3 code, so that if some other developer runs your code in a different Python interpreter, the code still works. Moving on, let us dive into some more questions. Now we will be going into more of code related questions. So first of all, is self is self a keyword in Python? Well, turns out self is not a keyword in Python. So a lot of the times we will see code something like this. So we will have some class. So let us say class foo, and in this we will have some function. So let us say def spam. In the spam we will have the first argument as self, and then apart from that we might have several other arguments, right? Now if I print the self is a reference to the instance. But it turns out that I can rename this to anything. I can say some other variable name, other name over here as well. Right? I can totally say some other name over here as well. Also, I can do something else. So for example, I can come over here and I can say self equals to 3. And this code works. So over here we see that self is not a keyword. How do we know that this is not a keyword? Well, whenever we have a keyword, we cannot use that keyword as an identifier. We cannot use that keyword as a variable name. For example, I can't do something like this. I cannot do something like if equals to 3 because if is a keyword. I cannot use that as a variable name. If I do this, I will get a syntax error saying invalid syntax. Similarly, I can't use something like none equals to 3. Similarly, I can't use something like async equals to 3. Right? These are all keywords. Now, if you want to get a list of all the keywords in Python, well, Python provides a very nice library for that. So there's import keyword. You can import the keyword. And from this keyword library, what you can do is you can print the keyword dot kw list. And this will give you all the keywords that are defined in Python. Now, these keywords will change from version to version. For example, the async and await keywords were only recently introduced in Python. These were not available before Python 3.5. Similarly, a lot of the keywords were recently introduced in Python, and the number of keywords in Python will differ from version to version. But irrespective of what Python version you're using, you can always import the keyword library and you can print the list of keywords directly from it. Now that we're talking about keywords, let us quickly go over what each of these keywords are for. Okay. So what is the false keyword for? The false keyword is the inbuilt data type, which is a Boolean. Right. So we can have A equals to false. Similarly, the true keyword over here, B equals to true. These both are Boolean types, the inbuilt Boolean types. All right. What about the none keyword? So the none keyword is in fact like a null or a nil value in Python. Right. So if you're coming from other languages, you might have seen a null or nil value. In Python, we call that the none value, and none has the type none type. Right. So I can come over here and say that some value equals to none. So now we have false, none, and true, none. What about and? So we have several keywords over here. So we have this keyword and, we see this keyword or, we see this keyword not. So we see these three keywords, and, or, and not. What are these keywords about? Well, these keywords are the conditional statements, right? So these are the Boolean logical operators. Right? So for example, you can come over here and say x equals to true or false. What is true or false? Well, if you look at the Boolean tables of the or word, then you will see that true or false is in fact true. So if I print x over here, it comes out to be true. Similarly, we have and we have not. So if I say x equals to not or false, well, that will turn x into true value. All right. So far, we have covered false, none, true. We have covered and. What about as? What about as? So where do we see this as keyword? We see this as keyword typically in context managers, right? So for example, you might have seen something like with open some file name .txt, comma read as f. So what this is basically doing is it is creating this object and it is assigning that object to this variable f. So this as keyword is often used in context managers. Let us look at the next keyword, assert. Assert is used a lot in things like unit tests. So what assert does is assert basically tests Boolean conditions. So you can say something like assert 2 equals to 3. This is called an assertion error because 2 is not equal to 3. It will raise an assertion error. You can also put an optional message over here, and then the assertion error will come up with a message. Assert is used a lot in unit. Now we have async and await keywords. These are used with respect to coroutines in an asynchronous programming in Python. We have the break keyword, where break keyword is used in loops. So if you want to break out of a loop prematurely, then you can use a break keyword. Break keyword is valid both in for loops and in while loops in Python. The class keyword is to define classes, right? To define the object-oriented programming class in Python. The continue keyword once again is used in loops. Def is used to define a function. The del keyword is used to delete a particular variable. So currently I have x defined over here. If I say del x, now x is gone. Now if I try to print x, I will get a name error. That x is not defined. Del is used to delete a particular variable. Apart from deleting a particular variable, it can also delete values inside a variable. So I can come over here and I can say x equals to, let us say a list 1, 2, 3, and I can come over here and delete x of 1. This will basically do is it will delete the value at the index 1. All right. So the del keyword, as we see, is overloaded. It has multiple uses. The else if keyword and the if keyword, once again, these are just the control flow operators of Python, the if and else. Similarly, the else thing. Except is used for, as we can understand, exception handling. Finally is also used for exception handling. We will come over finally again. So in the later questions, we will see what finally is for. For is for looping. What is from used for in Python? From is often used for importing something, right? So you can say import random. I can import the random module, or I can say from random import the randin function. Right? This will import one particular variable from the random namespace, right? So from is used for that. Global is used to basically tell the Python that the current variable that I'm using is belonging to the global namespace. For example, I can come over here and say a equals to 10. Then I can define a function, therefore, and over here I can say global a. Now, if I change this value, so I can print a, I can call foo, and if I print a again, I will see that this global a has been changed. So this is done by specifying this as a global variable over here. I can, if I remove this particular line, then we will see that a was not changed. It remained 10. So that is what global is used for. We have covered if. Import is definitely for importing things. In is used once again in for loop. Is keyword, we will look at that later on. Is basically is used to do identity checking. Lambda functions, we will cover this. Non-local, once again, we will cover this in the scope part. We've already covered not, we have already covered or. What about pass? This is a very common interview question. What is pass in Python? I mean, this seems like a very simple question, but it is quite often asked in interviews. Yes, so pass is basically used as a placeholder. So whenever we have some syntax in Python, let us suppose we have an if block. So if condition, right? So if 10 is less than 20, right? Now, if inside this if block, I do not want to do anything, then I cannot leave this blank. So I can't say print, okay, I'm done over here. If I do something like this, I will get a syntax error. I will get an indentation error. It says that, hey, I don't understand this over here. There should be something inside this if block. If I don't want to do anything over here, but I still want to have it be syntactically correct, I can use the pass statement. Pass is the no operation statement of Python. So if I just do pass over here, then this thing works. All right. So pass is just a placeholder keyword that we use when we want to make sure that we are syntactically correct when the Python syntax expects a block, but we do not want to do anything. Right. So pass is just a no operation in Python. Okay. Let us see what other operators we have. Raise once again is used for exception handling. Return is used to return a particular value from a function. Try is used for exception handling. While is used for looping. With is used for context managers. We will take questions over the context manager things later on. Yield is used for generators. Once again, we will see this in some time. All right, cool. So that was all the keywords in Python. We are not going to cover all these particular concepts in detail in this particular session. So this session is for the Python interview questions. We are not going to teach you Python over here. However, whenever we come across a good interview question, we will explain that in depth. Okay. So if you want to learn any of these things more in depth, you can always reach out to our interview web page, and there you will find explanations. Or you can always reach out to me personally on LinkedIn and ask for help regarding any of these, and I will be very glad to help you out. Okay, let us move on then. What is raise? Raise is basically used to catch and raise exceptions. For example, I can come over here and I can say, so I could be doing something. So suppose I write a function, def divide, right? I'm writing this function. I get the numerator and I get the denominator. Now over here, I can check if the denominator is 0, then I want to raise an error. I want to raise an exception because, hey, the denominator dividing by 0 is not valid. I can come over here and I can say raise exception. I can create a new exception object and I can raise, hey, you cannot divide by 0. Right? So raise is used in this context. Otherwise, I can just return num divided by denominator. So if I call this function, if I call divide of 10 comma 20, then this works. But if I try to do something like divide of 10 comma 0, an exception gets raised and my custom exception gets raised. Right? My exception, hey, you cannot divide by 0, that gets raised. So that is what raise is used for. Whenever we use raise, we usually pass an exception with it, but it is not necessary that you pass an exception. For example, I could also come over here and say try to divide this. If we find an exception, if we find any exception, then just re-raise that exception. Right? So raise can also be used without any exception. So what this does is, whatever exception your try proc currently got, it will just re-raise that from the context. Okay. The raise keyword is same as true in Java. However, the raise keyword is kind of overloaded. For example, as we just saw, we can use raise keyword without an exception. We could also use something like raise from, right? So we can catch this exception as E, and then we could raise a new exception from E. Right? So raise is kind of overloaded. It has multiple syntactical uses. Apart from the normal raise exception thing that we usually see in Java, we have other variants of this raise keyword as well. Yes, we have covered all the keywords. Now let us move on to some built-in data types. So here's a very, very famous, very common interview question. What are the built-in data types that Python supports? What are the most common data types that Python supports? So if you're talking about languages like C and C++, or if you're talking about languages like Java, you have several built-in types. So you have things like arrays, you have things like integers, you have longs, you have floats, you have booleans, you have strings, you have byte, and things like that. What about Python? What built-in types does Python support? Well, yes, Python supports a large variety of types. So we have things like integers. So let me do something. Come over here and let me define a list. So let me say different values. Let me define a list of different values. And over here, I will have an integer. I can have something like a float. So I can have the value of pi, for example, an approximate value of pi. I can have a true and a false over here. So these are Boolean types. I can also have a none type over here. Then I might even have a string over here. Then I might have something like a tuple, so 1, 2, 3, or I might have a list 8, 2, 5, or I could even have a dictionary, so 1 to 1, 2 to 4, 3 to 9, or I can even have something like a set, so 1, 2, 3. This is a set. I can have something like a range, 2 to 5. I can have things like a frozen set, so 1, 2, 3. So these are all the different values. Now let me quickly loop over each value for value in values. Now what I'm going to do is I'm going to print the type of this value, and I'm also going to print the value itself. So we will see what the different types of these values are. So we see that 10 is an integer, 3.141 is a float, true is a boolean, none has the type none type, Python is a string, right? This particular thing in the quotes is a string. This is a tuple, this is a list, this is a dictionary, this is a set, this is a range, and this is a frozen set. All right. Apart from that, we have something that is not commonly seen in other languages, a complex data type. So I can do something like 1 plus 2j, and what this represents is a complex number. So 1 plus 2j is in fact a complex number. All right. So these are all the different data types that Python supports. Okay. Now, what is frozen set? A frozen set is just a set which is immutable, right? So basically, if I have something like a set, so I can say set 1, so I can say value 1 equals to set, right? Or I can say value 2 equals to, I can also define a set using this particular notation, right? So both value1 and value2 are set. Now what I can come over here and do, what I can do is I can say value2 dot add some other value. So what this does is it changes this particular set. It adds something to it. Oftentimes we would like to have sets which are not changeable. So if you want a set that you cannot change, but you can still do set intersections with it, you can still find the length of that set. We want everything that behaves like a set, but you cannot change it. That is called a frozen set. If I just say frozen equals to frozen set of 1, 2, 3, if I say this, now I have a frozen set. Now if I try to add something to it, I will get an attribute error which says that frozen set has no attribute called add. I cannot add to a frozen set. All right, cool. So let us look at some more questions. So one very famous question is this: what is step 8 and why it is important? Why is it important? So first of all, what is this thing called PEP? So PEPs are actually Python enhancement specifications, right? So Python enhancement proposal. There's a huge list of this. So what I can do is I can go to python.org, and we can also go to the PEP 008 over there and see what this PEP is actually about. 0008, my bad. Right. So this is the PEP 8, and what PEP 8 is? It is a style guide for the Python code. So it basically tells you how your Python code should look like, what the indentation should be, do you use tabs or spaces, what should the maximum length of line be, what type of string should you use, how should you properly import things, how should you have comments, how should you specify documentation strings, and all these things. So this basically tells you what beautiful, what idiomatic, properly formatted Python code is. Right. So PEP 8 is a Python enhancement proposal that basically gives you the guidelines. So once again, these are not rules. Right? The PEP 8 does not give you rules. It gives you a good set of guidelines that you should follow to make sure that your Python code looks good. It is formatted properly, right? To make sure your code is formatted properly. Right? That is what PEP 8 is. Now, a lot of the organizations will follow some format of PEP 8. They might not follow PEP 8 strictly. For example, PEP 8 says that whenever you are dealing with Python code, the Python code should not have more than 80 characters in any line. Now, this was enforced way back in the 90s when we were working with terminals. Terminals usually had an 80 character width. So if you had any Python line, any code line that was more than 80 characters, then it would either scroll or it would wrap down. Right? So that is where this particular guideline comes from. Now, on modern systems, it is very common for your monitors or whatever system you're using to have support way more than 80 characters. For example, if I try to write down how many characters this particular screen can support, I will be able to fit way more than 80 characters. So limiting your code to just 80 characters width is probably not something that you should be following right now in this modern world. So a lot of the organizations will follow PEP 8, but they might violate some of the conditions of PEP 8, and that is basically fine because PEP 8 is a set of guidelines. It is not a set of rules. However, if you want your code to be idiomatic, to be properly formatted, and to be readable to other Python developers, it is strongly recommended that you follow at least some basic guidelines of PEP 8. All right, and that is why PEP 8 is important. Now, there are a lot of formatters like Black. There are a lot of linters that basically lint PEP 8 errors that will basically automatically make sure that your code is PEP 8 compliant. Right? All the modern IDEs support PEP 8 for compliance, and if you are using something that is not an IDE, something like Vim or something like VS Code or something like Sublime Text, you can always add add-ons that will make sure that your code is still PEP 8 compliant. All right, cool. Now, with PEP 8, there's a common question that comes, and that question is, what are these things? So, what is PEP? Is PEP the same as PEP? What is PyPI? Right, so these are all very confusing names, and it is important for you as a Python developer to understand these things. These can very well come in as an interview question. Right, so these things are different. PEP stands for Python Enhancement Proposal. Right, this is what we just saw. Right, so PEP 8 is one of the PEPs. There are many PEPs. All right, PEP is the default package. So this is the package installer for Python. Right, so let me quickly open up a terminal for you guys. So what we see is let's say that we have Python 3 over here, and currently if I try to import this module TLDR, I won't be able to import this module, right? So I hope that you can see this code. So I tried to import this module TLDR and it said that, hey, no module named TLDR. So what I can do is using pip, I can install this particular module, TLDR. So it will basically install this module for me. Or if I go back to Python 3, now I can successfully import this module from my command line. Okay, this does not work. So let's try something else. So maybe I can try importing PQDM. So basically the pip module. So pip minus help. This is a Python package installer. This is a package installer for Python. All right. Cool. What about PyPI? Well, PyPI is the Python package index, right? Whatever modules or libraries that you can install via pip, they are available on the PyPI index. So you can go to pypi.org and pypi.org. So as you see, this is the Python package index, and this lists down all the different packages that you can install via pip. Right, so this has thousands and thousands of packages. So you over here you can see there's a 240,000 different projects, and you will see all sorts of things over here. So all things like Flask and things like Django, all these different modules will be available on the PyPI. All right. Yes. So pip is just like npm. So it is a package manager, and PyPI is actually the index where all these packages are stored. All right. Cool. Moving on. Let us dive into some actual code of Python. All right. Now, one very common question once again is, what is the difference between tuple versus list in Python? Right, so what is the difference between a tuple and a list? So for one thing, tuples are immutable. Right. So basically, if I define a tuple, I cannot change it. For example, if I say a equals to 1, 2, 3, right, I can print the type of a. So the type of a is tuple. And if I try to change the second value of a, then it will give me an error saying that tuple object does not support item assignment, right? Tuples are immutable. On the other hand, a list, let us say L equals to 1, 2, 3, lists are mutable. So I can print the type of a list over here. So this is a list in fact, and I can come over here and say list of 2 equals to A. And this will work. So this has changed the list. So lists are mutable. So that is one of the key differences of tuples and a list. There are several other syntactical differences. For example, you must have already noticed that if I'm defining a tuple, so I define the tuple using this parenthesis syntax. So 1, 2, 3, this is a tuple. Whereas for a list, I use the square bracket. Right? For a list, I use the square bracket. So this is the syntactical difference. There's one more important difference. For a tuple, for defining a tuple, I can sometimes omit these parentheses. So I can also come over here. I can omit these parentheses. I can define this tuple as 1, 2, and 3. Right? If I do that, then by default, the type of T will be a tuple. Right? So omitting this syntax leads a tuple. I cannot do that with a list. If I try to define a list 1, 2, 3 like this, then L will in fact turn out to be a type tuple. All right. So for tuples, I can omit these parentheses. Now this is very important because this allows us to very easily form tuples, combine values, and use those values. So I can, let us say I have a function over here. I can define a function foo that takes a value a and takes a value b, and it can return a plus b, and maybe a minus b as well. So this function returns 3 values. So if you were doing this in something like C++, you would have done something like foo returns a type of pair of int comma int with an int, right? You would have done something like this to return 3 values. In Python, you can do that very simply by just returning a tuple. Okay, so that is the core differences between a tuple and a list. All right. Now there's one common mistake that people come up when talking about tuples. So for example, if I do something like this, of a comma b, and I try to return a minus b, but I have a leading comma over there. Right? Let us try to see what this does. So if I call print, so if I let me say value equals to foo of 10 comma 5, right? And if I try to print the value, or if I try to print the type of value, I will see that the type of value is a tuple. Even though I supposedly I return an int, but the value is a tuple, that is because I have this leading comma. Right? So just by putting this comma, I have converted this into a tuple. If I want to make sure that this is an int, I better not have a leading comma over here. So if I do this, now the value will be an integer. Is that clear? So be careful about that. All right. Now this is a very common question, and this is a very important question. So the question goes something like this. Suppose you wanted to, so if you have to print the elements of a dictionary in the order of insertion, how would you do that? Yes. So basically, what we mean is, let us suppose I define a dictionary. So I say D equals to some dictionary over here. Right? This is an empty dictionary. Then I can come over here and say that D of A equals to 10. I can say that D of C equals to 20. I can say that D of X equals to 30. Right? And I can also say D of B equals to 40. Now what I want to do is, I want to somehow iterate over this dictionary in the order of insertion of values. So basically, what I want to do, so let's quickly see what happens currently. So if I do something like for key comma value in d dot items, print key comma value. So let us see what happens over here. So it prints A, C, X, and B. It seems that it actually printed things in the order in which the elements were inserted. Right? So E was inserted first, it printed out A first. C was inserted next, it printed out C next. X was inserted next, and so on. So this seems to be the correct way of printing the elements of a particular dictionary in the order of insertion. Is this correct? Well, this is a tricky question. So let us look at some history of Python. So currently the version of Python I'm using, so I'll quickly do this for you guys so that you can see that I'm currently on Python 3.8.1. And in 3.8.1, yes, this is true. In Python 3.8, yes, this is true that the dics are inherently ordered. However, in older versions of Python, this was not true. Okay. So basically in Python 2, all the way to Python, in all the Python versions up till 3.5, in every Python version less than or equal to 3.5, right, dics were not ordered. What does this mean? This means that if you have a dictionary and you insert keys in the order of A, B, C, D, E, F, right? You insert keys in some order, and if you try to loop over this list, so if you try to do something like for key in dict, right? If you do something like this, it is not guaranteed that you get the keys in the same order. You can get these keys in any order, in any particular order, and that particular order is basically determined by the hash value of these keys, right? So depending on what the value of hash of A is, you will get the keys in the hash order and not the actual insertion order. Right? That was true for a lot of Python versions. Now, this was a common pain point for a lot of Python developers. A lot of the novice Python developers, they assumed that whenever you iterate over a particular dictionary, you will get the values in the same order of insertion, which was not true. Which is why in some Python, versions, what the dev said was, let us randomize the order, right? So for example, in several versions of Python, when you try to loop over a dictionary, you will get the same value again and again. You will get the same order of keys again and again. That order will be different from the order of insertion. However, that order will not change. Okay. So if your order of insertion was this, let us say that this was your order of insertion, it could be the case that when you iterate over the dictionary, you get this in this order. But no matter how many times you iterate over the dictionary, you will always get this in the same order. You will always get this in this order. This was true when Python was using the hash value of the key, right, to determine how to iterate over it. Now, in some versions of Python, what the developers said was, the developers said that, hey, people are trying to abuse this, right? People are misusing this particular feature. So let us randomize the order so that people will see that whenever you try to iterate of the dictionary, it comes out in random order. Right? So that people are discouraged from using this property. Okay. So in some Python version, the order might be even random. Now from Python 3.6, so what happened? Let's talk about Python 3.6 for now. In Python 3.6, what happened was the dictionary was still unordered in Python, right? For the Python specification. In the Python specification, there was no change. Right? The dictionaries were still unordered. However, in the CPython interpreter, right? In the CPython interpreter, the dictionaries were ordered, right? Ordered in the order of insertion. All right. This was just an implementation detail. This was just the fact that CPython was doing it this way. If you go to Python 3.6 and if you try to do the same in PyPy, you might not get the same results. So in CPython 3.6, this was just an implementation detail. However, from Python 3.7 onwards, dictionaries are always ordered, right? And this is now a part of the Python specification. So basically, no matter what interpreter you're using, as long as that interpreter is talking about Python 3.7 onwards, it is guaranteed that a dictionary is ordered in the order of insertion. All right. Now, this is a very common interview question because whenever you're working in an industry, this bites a lot of people a lot of the times. For example, let us suppose that you are developing some code, right? So you are at Google and you are developing some particular piece of code that you intend to run in Python 3.8, right? Now you intend to run this code in Python 3.8 and you understand that in Python 3.8, the dictionaries are always ordered. So you use this fact, right? You use the fact that dictionaries are ordered. However, one of your colleagues tries to execute a code and that colleague has Python 3.5. That colleague of yours has Python 3.5 installed on your system, on his system, right? On his or her system. So what will happen to that particular person? Your code, which worked in Python 3.8, might break on their system because they were using Python 3.5, and in Python 3.5, bits are not ordered. Okay, so even though this is true, even though you know that in Python 3.7 onwards the dictionary is always ordered, please make sure that you never rely on that. Okay, and in fact, if you still want your dictionaries to be ordered, you can use something like the ordered dict. So ordered dict is available in Python. Ordered dicts are guaranteed, are always guaranteed to basically possess the insertion order. All right, and this is true irrespective of the Python version that you're using. So if you want to rely on this property of dict, then please use ordered dict. Do not assume that the person will be using Python 3.7 or a higher interpreter. It could always be the case that you are, because you are not coding alone, you're writing some code for a large organization and you cannot guarantee what the other person is using, right? What interpreter the other person is using. All right, and this is a very common interview question. Okay, let us see if we have any questions so far, and then we will continue. Uh, all right. Okay. Siddharth says, I'm confused with C, Python, PyPy, etc. Can you please take 2 more minutes on it? Sure. So once again, C, Python. So let me quickly tell you the thing. So C, Python. So Python is the language specification, right? What the Python language specification tells you is it tells you things about things like syntax. It tells you things like semantics. It tells you things like what the library function should do, right? What the libraries are available, what the library functions do, and so on and so forth. Now, this Python specification, this is just some text, right? This is just some rules and some guidelines that you have laid down. By itself, Python cannot do anything, right? Python is just a book. Python is just a piece of guidelines that is laid down that, hey, this is Python. It is just a concept. Okay, so Python is a language. Now, if you want to enforce that language, or if you want to be able to do something with that language, you have to implement that language, right? Basically, you have to implement some sort of a compiler for that language, or maybe you have to implement some sort of an interpreter for that language, right? So, for example, let us say that we are talking about C++. So, C++ once again is a language specification. Now, if you want to implement this language, you can have a compiler like GCC that compiles C++ code. All right. Similarly, in Python, we have several interpreters because Python is not a compiled language. Python is an interpreted language. In Python, we have several interpreters for Python. Right. Now, the most common interpreter, the default interpreter that you get for Python is called CPython. So whenever you go to python.org and you download Python from there, or whenever you are on say Ubuntu and you have the default Python installed in your system on Ubuntu or Mac or even on Windows, that is the CPython version. So this is the CPython interpreter. Now, CPython is not the only interpreter. There are many more interpreters of Python, namely things like Jython, IronPython, PyPy, right? Brython, Stackless Python, and many more. Okay, so there are many interpreters of Python. Now, where these interpreters differ is so all of these interpreters they at least follow the Python specification. So these interpreters at least follow the Python language specification. Where they differ is what additional things they provide. So, for example, in CPython allows you to import and run C libraries and code, right, from Python. On the other hand, Jython, this allows you to use Java. IronPython allows you to use .NET code, right? PyPy PyPy has a just-in-time compiler, right? So it runs very fast. Python allows you to run Python in the browser, right? Stackless Python and so on and so forth. They have other such features. Is that clear now? Cool. So one more common question that we have over here is, what is wrong? So what is wrong with import asterisk, right? So all of you know how to import all the things. So you see import asterisk in Java as well. So for example, what I can do over here, I can say from random import asterisk, right? So this is a way I can import things. This is a way I can import stuff from module. The question is, what is wrong with this? Why is this bad? Well, if you import everything from a particular module, what that does is it pollutes your namespace, right? For example, let us say that I have my function over here. So let us say that I have my function randint over here. And what this randint is supposed to do is, it is supposed to, let's say, return the value 4. And you can say chosen via a dice roll, right? So let us say that we have this random function. If I import everything from random, what will happen is, if I call this random function now, I will see that I'm getting a type error. This is weird, right? My random function is not supposed to accept any parameters. But I still can't call it. The reason why I can't call it is, when I imported everything from this random module, turns out that this random module also had a function called randint. And when I imported it, it basically overwrote this particular function, right? So the randint inside the random module, it overwrote my function. So this is a common thing that we see. So whenever you're talking about code, it could be the case that you have multiple variables or multiple functions that have the same name, right? But do different things. So how do you differentiate between these two things? You differentiate between these different variables and different functions using something called namespaces. So basically what we say is, we say random.randint is different from some other module dot randint, right? Both the functions have the same name, randint, but since they live in different namespaces, I can still treat them differently. Python understands that they are different. If I import everything from a particular module, first of all, this pollutes your namespace, right? So now, whatever, if you have overlapping names in your namespace, they will all get overwritten. That's the first thing. The second thing is, it becomes difficult to understand where a function is coming from, right? Where a function is coming from. So let us suppose I do something like this. So suppose I have some code, I have some values equals to 1, 3, 1, 4, 3, 2, or 5. Or let me say something like this, right? And I have import random, right? And I can do print random.choice values, right? And what this will do is, it will select one value at random from this list and it will give it to me. Now contrast this code from this code. Random import asterisk values equals to 1, 4, 3, 2, 5, print choice values, right? Now these two pieces of code, they do exactly the same thing. They take one random value from this list and they print it out. However, if my code is very large, right, if I have a lot of things over here, then to someone who is reading my code, they might not be able to understand very quickly where this function comes from, right? They might try to look for this choice function in this code. So currently it is still understandable that, hey, I don't have choice defined over here, so it must be coming from the random module. But what if I have other modules as well? So let us say from request. So what if I say something like this, right? Now how do I know where this choice method comes? It could come from random. It could also come from request. So this code very quickly becomes unreadable, right? So it becomes difficult to identify where these values are coming from, where these functions are coming from, which is why this import asterisk syntax, it is frowned upon. It is bad syntax. Okay. It is always better that you do not import everything from a module. You just import the namespace itself, and then you can refer to things by using the dot operator. So you can do random.choice. All right. Okay. Cool. Let us quickly take a couple more questions and then we can end the session. All right. So here's one common question. So the question is, what is the difference between something like a list comprehension and a tuple comprehension, right? So before we are able to answer this question, we should first know what a list comprehension, what a dictionary comprehension, and maybe what a tuple comprehension is, right? So basically, what a list comprehension is. So let us say that I have the list of squares, right? So what I can do is I want to store the squares of first 10 natural numbers in this list, or the first 10 whole numbers in this list. So what I can do is I can say for I in range 10, and I can say squares dot append I into I, right? And then if I print squares, this is what I will get. I will get all the squares of all the whole numbers from 0 to 9. Okay. This is a very common pattern, right? A lot of the times, what we see is we define an empty list and we add elements to that empty list, right? We keep on appending elements to that list. Now, Python provides a different syntax for this called a list comprehension. Comprehension, right? What a list comprehension allows you to do is it allows you to write the same code in a different manner. So now you can come over here and say, you can say squares equals to I times I for I in range 10, right? So this is what a list comprehension looks like. And at the end, you get the same result, right? You get the same result. Now, it is important to understand what the syntax of this list comprehension is. So whatever you have over here, that will be appended to the list. Okay. This for loop looks very similar to this for loop. Apart from that, we can have several other things. So I can maybe have the squares of only odd numbers, right? So I can say if I mod 2 equals to 1, this will give me the square of only odd numbers. I can also come over here and I can nest the loop. So for I can say for j in range 10. So this will give me repetition. This will give me every previous value. It will be repeated 10 times, right? So these are list comprehensions. You can go and read more about list comprehensions and dict comprehensions on your own. Now, just like these list comprehensions, we have things called dictionary comprehension. So I can come over here and I can say squares equals to, so I can, let me say cubes this time. I can say cubes equals to the key to a particular value, I to the power 3 for I in range 10, right? So if I do this and if I print out the value of cubes now, I will see that this is a dictionary which holds the key and the corresponding value. So I see over here that the cube of 2 is 8, the cube of 6 is 216, and so on, right? Similarly, so this is a list comprehension. This is a dictionary comprehension. Similarly, we have something called a tuple comprehension. Now, tuple comprehension behaves a little differently. For example, let us say that I come over here and I say the whole numbers. So I say something like this. So I say I for I in range 10. So what I'm expecting over here is what I really expect to see is I expect to see this thing 0, 1, 2, 3 all the way till 9. So this is what I expect to see in the output. But let us see what we actually get. We get back a generator object. This is really surprising. So in fact, this is not tuple comprehension. This is a generator expression, right? This is the correct terminology for a tuple comprehension is actually a generator expression. All right. Now, these generator expressions, they come handy in a lot of different scenarios. Basically, what this generator expression does is it generates these values one by one. So let me quickly show you an example of that. So let us suppose that I have a large list, right? Large list. Let us say I have all the numbers for I in range in 1 E7, right? So I'm going to create a list of all the numbers from 0 till 10 to the power 7 minus 1, right? So let us see how much time this takes. So I'm going to execute this now. So I just executed this and let us see how much time this took. So this took a fraction of a second. Let me try to increase this value. So now I'm generating 10 to the power 8 different values. So that is 1 crore different values. And we see that this is taking a considerable amount of time. It is taking a large amount of time to generate this list because it is actually going on. It is going to the memory. It is creating all these objects in the memory. It is actually going to create this list. So if I do length of large list, I see that this list is actually this long. On the other hand, what I can do is I can say a generator list. I can say generator list equals to I for I in range. And it doesn't really matter how large a value I have over here. I can even have 10 to the power 20 elements over here. And when I execute this, it returns back immediately. Right? It returns back immediately. Because in fact, it did not create a list. It did not create the entire list in memory. It just said that, okay, you want this list? Let me generate this list whenever you need it. So this is basically what is called a lazy computation. So whenever we are using this generator expression, what this give us back is a generator object. Right? They give us back a generator object. So what I can do from here is I can say next of generator list. If I do this, I will get the next value in that generator list. So I can keep calling next again and again. I will keep getting the next value in this list. All right. So similarly, I can do maybe the squares of values. So now if I do, I will keep getting the next value. So I get 1, then I'll get 4, then I'll get 9, then I'll get 16, and so on. The entire list is not created on the fly. So for example, I can't do something like this. I can't do the length of generator list because this list is not created in the memory. If I try to call the length of this, what it will actually do is it will try to create that list. So this is taking time. Right? Creating the generator list did not take time. Taking the length of this is taking time because it is actually going to try to create that entire list. And finally, it tells me that, hey, the generator object does not support this length operation. All right. So that is the difference between a tuple comprehension and a list comprehension. There is basically nothing like a tuple comprehension. It is actually a generator expression. Right. So let me correct this. This is actually a generator expression. Now, generator expressions come a lot of the time very handy. For example, let us suppose that I want to add all the values from 1 to 100. Right. So how do you propose I do that? I can do something like this. I can say that, okay, total equals to 0. Then I can say for I in range 100, and I can say total plus equals to I, and then I can print total. Right? This is one way to add all the values from 0 to 100. On the other hand, what I can also do is I can do something like this. Sum of I for I in range 100. Now basically over here, I used a list comprehension. Right? I created this list and I used this list comprehension. However, when I'm creating this list, can you discuss the memory requirements of both these pieces of code? The memory requirement of this piece of code is just order of 1. Right? This takes a constant amount of memory because I only have a couple of variables at any time. I have total and I have I. On the other hand, for this piece of code, I am actually creating this entire list first in the memory, and then I am calling this sum over there. So the memory requirements of this are very large. On the other hand, if I use a generator expression, then the memory requirements of these become the same as the previous code. Now we see over here that this code actually did not run because the reason it did not run was because I missed a parenthesis over there. So now this code, this will use the generator expression and it will actually not create the entire list in memory. Now the cool thing about this is that you can omit these braces. So what I can do is, so notice that if I had a list comprehension, I would have this thing over here, right? Or similarly, if I want to have a generator expression, I should ideally, instead of these square brackets, I should have these round brackets, right? But turns out I can actually omit these. I can actually omit these completely and I can still do it. So this thing still gives me the same answer. For generator expressions, I can omit the brackets as long as I'm calling them inside a function. All right. I guess let us take just one more question. So one very common question that we see in Python is, so the question goes something like this, that what sort of garbage collector does Python use? Or basically explain how the Python GC works. Or in fact, this can come in several other ways. So a lot of, once I was asked in a particular interview, I was asked this question that, hey, you are noticing something, right? So you notice this, that you are running your Python code and you're monitoring how that Python code is running. So suppose that your Python code is printing some values and you see that it continuously prints some values. However, after some time, it suddenly pauses, right? The printing of the values suddenly pauses and then after some time it resumes again. So it could be the case that you are doing something like this. So you have some particular piece of code. So you have some values over here. You have a dictionary over here. You have a loop for I in range, let's say 10,000, and you are doing something over here and you're printing some value over here as well. So what you are seeing is 1 gets printed, 2 gets printed, 3 gets printed, and it is running smoothly. However, at some particular value, at some, let's say 1490, some particular value, there's a pause. There's a sudden pause. After that sudden pause, it pauses for a couple of seconds and then it continues. So it continues with 1491 and then it runs smoothly again. So this was running smoothly. There was a sudden pause, then it was running smoothly again. Then again, after some values, there was again a pause and then it starts running smoothly again. So what is going on over here? It could be the case that this does not work for your use case. Right? So suppose that you are using you are working on some sort of a producer consumer problem. Right? Now what happens if your process, so suppose you are a consumer, right? You are working in a consumer process and your consumer suddenly pauses. What can happen in that case? So well, what can happen is your queue can overflow. right? If suddenly all the producers keep producing, but all the consumers suddenly pause, then your queue can overflow, right? So you do not want this to happen. So what can you do over here? Right? So this is basically caused by the garbage collector of Python. So this is a very common way in which this question is posed. So let us quickly talk about the garbage collector of Python. So first of all, what does garbage collection mean? So in a lot of languages like C++ or C or C++, we have manual memory management. What this means is that either you have a variable like int array of size 10 that the compiler knows. Whenever your code is being compiled, the compiler knows that, hey, you're talking about an array of size 10 and it will allocate some memory for it on the stack. On the other hand, if you do something like this, if you declare a pointer of AR and then you say AR equals to malloc, right, you allocate some memory using the malloc command. If you do something like this, what C++ will do is it will allocate the space on the heap. Now, once C has allocated the space on the heap, C++ is not going to free that memory, not going to free that memory automatically. You have to do it manually. You have to free the memory manually. Now, of course, you can do that, but this has a lot of tricky business. So, for example, what if you forget to free the memory? What happens then? Well, this is called a memory leak. And a lot of the times, if you notice that you have a very simple program, or if you're coding in C++, for example, you have a very simple program, but the memory usage of that program keeps on getting larger and larger, even though it should not be using so much memory, but it seems that the memory requirement is continuously growing up, then that suggests that you have some sort of a memory leak. There are other cases as well. What if you free the memory, but you then try to use it? That can totally happen, right? So, for example, consider a situation like this. I declared an array, right? I declared an array and I said, let me allocate some memory. Let me allocate some memory into this. So I call this function func with AR, and then I decide to free this memory location AR. Let us say that I'm doing something like this in C++. What can happen is I am thinking that, hey, after this point, I won't need the AR, so I can free it. However, it could happen that this particular function, pass this memory location to some other process, right? Or some other thing, some other particular piece of code that will try to use this AR, this memory location after I have freed it. Now, if I do something like this, I can run into all sorts of weird segmentation faults, right? Or because I'm trying to basically free a memory location that does not exist, that I do not own. Manual memory management runs into all these sort of weird problems. Now, for this reason, several languages that try to be more programmer friendly. I mean, I cannot say that manual memory management is bad and automatic memory management is good, nothing like that. But manual memory management is tedious. Automatic memory management is a little easier for us. For beginner programmers, automatic memory management is a little easier. So languages like Python, languages like Java, languages like JavaScript, right? Languages like Ruby, all these provide something called a garbage collector. All these provide something called a garbage collector. And what this garbage collector does is it handles the task of freeing memory for you. So you can only allocate memory. So in Python, you can say L equals to, let's say, list of range of 100. So over here, when you do this, some space is allocated in your memory. However, you cannot free it. So one more question that frequently comes up is, if I call del of L, if I do del of L, am I not freeing the memory up? Well, in fact, this does not free the memory, right? What del of L just does is it says that delete, basically unbind the local variable L. Right? This is all it is doing. It is saying that there was a variable X, there was a variable L that was pointing to some location in memory. Just remove that variable. That memory is still allocated. That memory has not been freed. Just unbind that particular variable. That variable does not exist anymore. That memory is still being allocated. All right. So del of L does not actually free the memory. Well, if del of L does not free the memory, then don't we have a memory leak? Well, yes, we do have a memory leak, but we don't have a memory leak because the garbage collector will handle it for us. Now let us quickly see how the garbage collector works. So let me take an example. Let me say that I have some variable over here. So I have x equals to 10. Okay, I have x equals to 10. Now let me import the sys module. Right. So in this sys module, we have a function called getRefCount. So what I can do is I can use this function and I can say sys.getRefCount of x. What this will say is, this will basically tell me how many different variables in my Python code are referencing this same particular memory location. So let us quickly break down and see what is happening over here. So when I do x equals to 10, what actually happens is, what Python says is, let me take this value 10 and let me put it in some memory address. After that, let me create a variable called x. So I have a memory address, let's say 1024, and in this 1024, I put the value 10. Right? This is what I have done. When I say x equals to 10, what happens is x is now pointing to this location 1024. Okay, this is what happens when I say x equals to 10. Now, what else could be that there is another variable, let's say y, which is also pointing to 1024. There is another variable z, which is also pointing to 1024. Sys.getRef count will tell you, this will tell you all the different this will tell you the number of different variable names. Right? This will tell you the number of different variables that are pointing to this memory location. So if I look at how many variables are pointing to the memory location in which the value 10 is stored, I get back that, hey, 161 different variables are pointing to that. Now, I mean, I just declared 10, right? So how can 161 different variables be pointing to that? Well, it turns out that Python does some caching. For some smaller ints, Python does some caching. On the other hand, if I do something like this, if I have a large random number, and now if I try to get the count, I see that the count is just 2. So if I do something like something else over here as well, so hello from Python, right? If I do this, I see that the count once again is just 2. Why is the count 2? Well, for one thing, I'm using this x over here, and for other thing, I'm passing this x in the function as well, right? So there are two particular references to x. First reference is this particular local variable x. The second reference is inside this function. Inside this function, where it is accepting a particular parameter x, that will also be pointing to the same memory location, which is why I see that the reference count of this is 2. Okay, so what Python basically does is, for every object, it keeps a count of how many variables are pointing to it. Okay, so basically what I'm going to do is, I am saying that, okay, sys.getRef count x. Let me do one more thing. Let me say y equals to x. Now when I do that, I see that the ref count of x has increased. So ref count is now 3 because there are 3 variables, x pointing to it, y pointing to it, and the local variable and the parameter of getRef count is also pointing to it. Now if I delete y, let us suppose I delete y, and once again I get the ref count of x. Now what will happen? The ref count of x will drop to 2 again, because now the one count has decreased for the value y. Y is no longer pointing to it. So basically what Python's garbage collector will do is, it is a ref counting. Right? It is a simple ref counting garbage collector. So what it will do is, whenever the count of any particular memory location, whenever the count drops to 0, that means that there are no variables referencing to it. If there are no variables referencing to it, that means that nobody is using it. And if nobody is using it, then I can free that memory up. Does that make sense? So what the GC basically does is, it keeps track of how many variables are referencing a memory location. And whenever the count drops to 0, it frees up that memory location. Right? This is what the garbage collection is. So this is the basic garbage collector of Python. However, that is not the complete story. So let us look at an example. So let us suppose that I have something like this. So say that I have a list L, and in this list I have a value 1, 2, and 3. So what I can also do is, in this list itself, so let me basically print sys.getRef count of L. Okay, so let us see what we see over here. We see that there are two values referencing to this. Okay. Now, if I say L.append L itself, so what this does is, in the list itself, it is appending the same list. Okay. Now, the reference count of this particular list has increased to 3. But let us ask ourselves this: even if we delete the variable L over here, will the ref count drop to 0? No, it will not. Why? Because the list itself has a reference to itself. Right? The list itself contains a reference to the same memory location. So the reference count of this particular list can never drop to 0. Right? If it can never drop to 0, then the garbage collector will never be able to collect it, and that will cause a memory leak. Which is why almost all the garbage collectors do something else as well. They basically, after every short amount of time, like some time, they will go over all the particular variables, and they will see which variables are reachable. So think of this like a graph. You have several variables. Variables that are pointing to some memory locations. All these memory locations are therefore reachable. Now, if the values stored in these memory locations are also pointing to some other memory locations, then those other memory locations are also reachable. However, it could be the case that there is some memory location M which is pointing to memory location N, and this n is also pointing to n. There is nothing outside of this particular loop. If there is nothing outside of this particular loop that is pointing to any of these memory locations, then these memory locations form a connected component, right? They form a connected component in the memory graph. Nothing from the outside is referencing them. However, they can't be garbage collected directly. What the garbage collector does is it periodically runs a certain cycle or certain loop to check if there are any such self-referential memory locations, and it will free all those self-referential memory locations that are otherwise unreachable. All right, and this periodic check is actually what causes this periodic slowdown. Right? So we saw over here that this code was running smoothly, and after some time there was a sudden pause. Then it was running smoothly. Then after some time it was a sudden pause. So these sudden pauses are caused usually by this garbage collector, by this cyclic checking of this garbage collector. Okay. Now Python garbage collector has several other things. So Python garbage collector is a generational garbage collector. What this basically means is it basically has three different queues or three different generations in which different memory addresses can fall. You can read more about the generational garbage collector. This is just an optimization that different garbage collectors do to make sure that they are not trying to check the same memory location again and again. Okay, you can go and read more about this. But this is a very common question once again in interviews, that how does the garbage collector work, or why do you suddenly have pauses in your Python program? And this is the basic answer. All right. If you want to learn more about the garbage collector of Python, you can always look up resources. You can always go back to the interview bit website as well, and you will be able to find more examples over there. All right. Thank you guys. Have a nice day. Bye bye.